that we have a lot of folks from JavaScript on this stage today. Yeah, I mean, we're taking over. No, I'm glad. We should have more participation. I know for a fact that there's a lot of folks from TC39 in town because we had it last week, and we should work together more. Okay. Oh, we have the stream up. It's your cue.
Thanks. I will get right into it. So JS engines, hopefully most people know what they are, but basically everyone knows what V8 is. It's what Chrome uses, what Node uses, what Dino uses. JavaScript core and SpiderMonkey are also very cool, but less prevalent, especially in the server-side space. But Bon is slowly changing that. So most JS engines probably 10, 20 years ago just did interpretation, which is you have your code, you just run it in your program in a loop, which is great because it's really simple. So it's pretty easy, but then also pretty slow. So V8 kind of pioneered just-in-time in Chrome, which is where you compile to machine code first and then execute, which is a lot more complicated, but also much faster. So because just-in-time engines have to compile, most modern JS engines kind of look like this, where you have to have several stages where you have an interpreter, then several just-in-time tiers where each one takes longer to compile, but also each one gets faster and faster at actually running that JavaScript. So yeah, just-in-time is great for performance, especially micro benchmarks, because then it's just basically raw throughput at that point. So you can get about 10 times faster. In the real world, it's kind of arguable. Like this is a study done by the Edge team for the super duper secure mode, where they see about a negligible difference in power, and then slower page loads, but also better startup times and memory usage. Another big con is security. Around half of all JS engines' security bugs are because of just-in-time. Another bad con is overhead, which is kind of less prevalent, but you can see here in a little benchmark, while it's much slower, it also uses about 20% less memory, which doesn't really matter for most use cases, but if you're, say, an embedded device, it kind of makes JITs a no-go depending on how small you are. So you also have ahead of time, which, like the most famous examples is C++ and Rust. You just give that to Clang or Rust C, and then you just get a binary. So like, can't we do this with JavaScript? Well, you can. So pull 4 is this. I started it in around October 2023, and then I did it full-time since August last year, since I got funding for it. So I will just go straight into a demo. So I have my little terminal here, if I can spell. So say I just write a nice cool script, like hello Hackfest. So I want to run that script, I can just use Node or something, great. But say I want a native binary because I want to ship it to a user and they have Node installed. I can do, say, like Dino's compile. So then I just have a little script which works. Or I can use buns, which does the same thing but is JavaScript core to have some representation. And yeah, that works just the same. The only kind of downside here is if you look at the binary sizes, they're slightly big. 100 megabytes is, I guess you can argue it's fine, but it's not ideal. So if I compile it with pull4, it's 20 kilobytes. Which is very nice, and it works just the same. With this simple example, it works really nicely because it's just a hello world. So you actually benchmark each of them running. Wait a second, because averages are cool. So you can see Dino takes around 50 milliseconds, 75 megs of memory, because it's an entire runtime. And yeah, pull4 takes around 1 meg of memory. Well, even bun takes around 32 and takes less than a millisecond because it's just as if you wrote it in C or something, which is nice. But say I need to compile to WebAssembly because like my client really cares about the JavaScript not being reverse engineered because who knows. So if I just have the same file, so the kind of industry standard today is Joyee, which just bundles QuickJS into the WebAssembly, because until now there's no real way to not do that. So that builds, which is fine. It's around 1 megabyte, which is much more reasonable than 100, but still not ideal. So if I compile the same with pull4, it is, yeah, 4 kilobytes, which is also nice, especially if you're, say, shipping this to a browser. That's like almost like 300 times less shipped through the network. And it's also much faster, but I won't demo that because WebAssembly is WebAssembly, which is hard to run on the server for now. So yeah, the architecture inside is pretty simple from a surface level view. You just take your JavaScript, make an abstract syntax tree, turn it to WebAssembly. It more kind of looks like this, which is you have built-in APIs like, say, date, string.prototype, everything like that. You can turn that to WebAssembly and then also optionally make that into C code in the native, because you can just write C code, give that to Clang, and you basically get LLVM optimization for free without having to tie into that. Undersimplified, my summary is optimization is important, especially for JavaScript, for better or for worse. So yeah, the main downside is you're reinventing the JS engine, so it currently passes around 59% of test 262, which is the entire JS spec test suite. So that includes everything from, say, adding 2 numbers or all of Temporal. So you might think, is this vaporware? Like, I just showed a binary on my machine. It's on GitHub right now, if you want to use it. One surprising thing is it's written entirely in JavaScript and TypeScript, because, I mean, honestly, when I was starting it, I thought it was funny. But the nice thing is, like, if you know JavaScript, you can just contribute to a JavaScript engine. You don't need Rust or C++. And yeah, it's around 20,000 lines, which is pretty small. I think V8 is 1 point something million. So, but like, that's very understandable because they have like that kind of required complexity for browsers. But because I'm targeting just like server-side, like non-browser use cases, it's fine if it takes, say, a minute to compile, because like the user is not waiting for that web page load. And yeah, so the code is kind of nice for the most part. Like, say so the top one is from the array prototype, which looks kind of nasty but obvious. And the second one is from date, which has some nice spec comments. It's, for the most part, just normal TypeScript. And yeah, please shout any questions or code to run in a REPL. Thanks. Yeah, I have a nice little REPL here. So you can just shout at me to run things and we can see how it breaks. Yeah, so stuff like with, yeah, so have I tried stuff like with, for now I treat with as like a no-op. So like, say you have, so this will just say A is not defined because I essentially ignore it for now. You know, I shouldn't. With an eval especially is not impossible for ahead of time, but very hard. Like, I know Hermes, the React Native JS engine, completely doesn't support with. But so say like eval, if you just give it a constant string, it works fine. But then if you say make this so you can't easily see it statically at compile time. So for this, I just have in a variable. It will say eval is not defined because in theory, you can do eval ahead of time by like shipping a mini JS engine in your output, but for now, I just hope most people don't need eval in 2025. Yeah, so right now I don't support proxy, but it seems very feasible. So like my object implementation is, I guess, ready for it, but just I've had like bigger things to deal with. Yeah, one thing I completely forgot to demo is. Oh yeah, so
I should shout this into the mic probably. Yeah, my question was like, how much type information do you take advantage of to avoid like, you know, JS, like when you compile any JS function, it can take whatever as an input, right? So.
Yeah, so one thing I completely forgot to demo is I also support TypeScript out of the box because you control the JS engine, so you can. So say I have, like I can define this as an I32 and then just like log that as an I32. So the compiler will see this type annotation and optimize just for that. So like say I do foo plus 2, you can't see the actual bytecode, but I will know like this cannot be a string concat because I know this is a number from this type definition. So yeah, in my experience, it can make a big difference, especially in like a really hot path. You can be around, I think like up to 2 times faster in my testing.
Yeah, what happens if you try and add a float to that number?
I think in this case it should. Yeah, it deops nicely.
Okay.
But in some cases it will just, I think the best example of this is, say I have like a byte string as a type, and I do some Unicode thing, which I've not prepared on brand. Yeah, it will just, yeah. So like say you try and add Unicode to a byte string, right now that will just break your string.
Okay. Yeah, I have another question, which is, I guess, just in general, aside from eval, are there any other features that you don't think will ever be possible or that you're worried about being difficult to implement?
Yeah, I guess for the most part it's just eval or say like new function, any like dynamic compiling things.
Given that your compiler is in JavaScript, would it be crazy to ship that for eval?
That is, I've considered that a lot. It's still far away because, for better or for worse, I'm like, oh, I love these new fancy JavaScript proposals. I use them on my compiler, then I have to support that if I want to compile myself. So it's like a goal, but at least for now, I hope I don't need to have it. But it's like if someone needs eval for a use case, which like they cannot use it, then I would definitely try and invest into that.
How do you deal with memory management? I assume you don't have to ship a GC all the time, like in the binary. But
yeah, so I guess right now my memory management is very simple. It's like my allocator is like I wrote it in a day, so it's definitely like I definitely leak memory in places. But I guess for now, for what I'm targeting, isn't really long running use cases. Like say you have like a AWS Lambda thing where it's like, I want this JS function to run on a web server to make a response in like 500 milliseconds. For that, you basically don't need a GC. You can just leak memory until you die. So yeah, it's definitely a problem long term, but at least for now, I've been limited by other things than like having a good allocator in GC.
Are the binary size savings compared to other runtimes that significant also when you have like realistic apps? Because like assume for just console log there is almost no stdlib you need to ship.
So say I have like an absolute worst case here, which is like I console.log global this. So like I have to include all of the built-ins, even this. Will fail to compile. Yeah. I should not have been doing commits last night. But in my experience, this still gets like at most 1 megabyte compared to like 100 of bundle nodes. So it definitely gets like worse as you include more, but it still limits itself nicely in my experience.
Do you have like a list of if you were the benevolent author of ECMAScript, is there anything that you would just remove that was too complex that like broke you?
Good question. I guess I can't think of anything too complex. I guess it's mostly the weird things which aren't specified for no reason. Like I guess like a big one is like say date.parse. That doesn't specify which date formats you have to support, so I kind of just used like the three most common ones and gave up because at least for now I'm not too focused on like node compatibility. Just like can it run JavaScript to the spec? But even some random things like say like array.sort isn't specified what algorithm to use. So you just kind of have to look at what JS engines use already to be like, that's probably good for performance and like spec compliance.
Yes, thanks, Oliver, for the presentation. So for Joyee, there is a separation between runtime and the actual bytecode of the JavaScript. So you can like split into, for example, WASM modules. Is it possible with your engine to split all built-ins in a separate WASM module?
Yeah, sorry.
Yeah, go ahead.
It's not possible right now, but it's definitely feasible because, like, say, like I have a script here, which I just use some like random prototype just to kind of include it in the binary. So if I run this, it just logs that, but then if I run it with logging all the WebAssembly functions, some nasty things. But say like all these functions could just be split into another file easily because there's like a I guess standard like calling convention I use. So there's nothing where I like break built-ins between files to optimize that heavily. So it's definitely possible, just I've been limited by the things for now.
Yeah, thanks.
Right, I guess it's my chance to ask you a question. I know that you're using C as a cross-platform IR, but what are your challenges like in terms of using it instead of, say, emitting LVM IR or something more appropriate?
Yeah, I guess the hardest thing is making C which compilers can understand rather than people. Like, if I compile like that hello world, for example, to C, it looks awful. Yeah, it's
fun.
Awful because this is like WebAssembly transferred to C. But in my experience, compilers can deal with this pretty well, even if it looks terrible. Like there's loads of temporary variables, but usually LLVM just optimizes them all out.
Right.
So
Like
yeah.
at this point, is it useful for you to emit C?
Yeah, I think it's more useful than, especially because like one example is say Zig. From the start, they relied on LLVM, which is great for optimization, but like the debug mode, they're writing their entire own x86 backend now, just to avoid LLVM, because otherwise it takes like minutes to compile, even in debug. So like, possibly I'll add like another backend using LLVM, but for now I'm happy to just have it so I can tell the compiler how to compile it and not rely on one like single backend.
Another question was that one thing you emphasized a lot on was the binary sizes, which was really impressive because you're not embedding an entire JavaScript engine. But how much do you think people actually value that in their day-to-day?
Yeah, I think it's definitely arguable. I think the main thing is, like, say you're an embedded device, that obviously matters a lot, because if you have, say, like 1 megabyte of storage, you can never ship that. You have to use, because like specialty engines for embedded already exist, but the spec compliance can be hit or miss, and the performance is like an interpreter, which is fine for most things, but if you have like a really performance limited use case, it can follow you a lot. So yeah, I think binary size matters, but I guess not a lot. But say it's like, oh, my app is 100 megabytes because I'm shipping Node and I update it once a week. That's like 400 megabytes a month per user. Someone has to pay for that bandwidth.
Yeah.
And if that was 1 instead of 100, that'd be much nicer.
Thanks. Any more questions? Nico?
Do you have an estimate of how much of, say, ES5 that you pass?
Yeah, so the question was, test 262 involves every single thing in the spec, so how much of ES5 do I pass? I think in terms of like what I have, say, in built-ins is most of it. I think the main thing I'm thinking of is like, say, with or eval. Of course, I don't support. I'm in the middle of rewriting my regex engine, so regex support is very hit or miss right now, but hopefully it should be much better. So I guess it's some like edge case things like that. But for the most part, most code, it's gone to the point of like most code will compile, but then there's a bug somewhere and it will crash. So it's more of a test of like endurance now rather than spec compliance.
So you mentioned that you've got 59% passing in test 262. How did you go about deciding what to implement? Is this kind of based on what's actually used and some of the lesser used stuff you've not implemented, or is it more just following the spec through?
Yeah, from the start it was definitely just following the spec of like a list of built-ins and just being like going through the list. Now it's mostly more of running things, seeing what breaks, and then trying to fix that. That's why there's, I guess like from the first glance there's a plateau there, but it's mostly just fixing things which aren't immediate in test 262. Like say regex things like will probably be flat until I actually finish it, then there'll be a huge spike. Because like just parsing regex won't get you any spec compliance because you're not actually running it. Or say, like a big one is say optimization, which you can't see in that graph, but like one classic V8 benchmark, which is Richard's. So this is just like a massively, essentially it's just loads of gross object prototype stuff, like worst case. So like that's basically the worst case for ahead of time because it's very hard to optimize prototype without breaking things. But right now I'm already faster than say QuickJS. Yeah, so around 2 times faster than QuickJS for that, which is nice, which is like not that important for just a micro benchmark, but say like objects generally are really important to make fast. So yeah, it's mostly just a mix of, I guess like what makes sense, I guess like ignoring the raw test 260 number and just focusing on like improving it generally.
What's your iterators and especially async iterators state?
Bad.
Yeah, I'm
That's
having a
my
hard
summary.
time with those as well.
Yeah, generators especially is very buggy. Like some stuff is fine, like say this. Like this is fine, but then if you do, like say some weird void star things. Actually, I think I support this now. Yeah, like stuff like this will break because generators is, I guess, less used today than it was, but like most things I tried to run don't have generators, so I haven't really focused on it. It's definitely possible, just not nice to do nicely, especially WebAssembly has no way to like do the control flow of generators, which is just pause this function. So yeah, it's definitely possible, just annoying.
Is that on? Yeah, Oliver. Did you mention yet where, is there one single big place that's a big chunk of the tests that you still need to get passing for 262?
Yeah, I actually have a script which I can just show live, which is looks at like the most common directories I fail, and unsurprisingly, it's temporal.
Yeah.
It's around 8%.
Yeah.
Yeah, then there's some stuff like regex and like annex B things, and yeah, other instances. other internationalization things, which I just haven't gotten around to.
Do you got a plan for focusing on that, or at
Yeah.
some particular point?
I mean, the dream for Temporal is, because it's all written in JavaScript and TypeScript, is I can just take a polyfill, like edit it slightly, and then have Temporal support for free, which is much harder than it sounds, but it'd be much nicer than just doing something from scratch.
What's the state of things with other contributors? Do you got some other people that have been contributing?
Yeah, so it was, I guess, no one until recently, but there's a few people now doing PRs, which is really nice, especially because like some commits are like as obvious as they seem. Like, I think there was one recently where it was like a bug in the array prototype, which is just like one line was in the wrong place. Well, like it was throwing earlier than it should have, and you just swap the lines around.
Cool.
Thanks.
Okay, I will ask the one question I just got curious about. As someone who started this project, what is your vision for this project? Like maybe, typical question next 5 years or 10 years?
Yeah, I mean, I guess to start it is, I just wanted a new side project, which I would never finish. And like, I knew this is, I mean, people didn't really call it impossible, but I knew it was like infeasible to do well. So I was like, I have free time, I might as well waste on something interesting. So since I like basically spiraled out of control, because I got funding last year, which was completely unexpected, and I was just like, sure, I'll work on this full time, because it's like, I don't know, the most interesting problem I find in JS, at least, myself.
Are you considering using the WebAssembly GC spec for your garbage collector, or are you shying away from it because of the difficulties with using that for the C output?
Yeah, I've looked at it not in full, but it's very interesting. I guess my kind of dream would be you have free modes, which is like Node.js if it's super short running, or WASM-GC, or my own GC. So say that you're shipping to embedded, you can use my own GC because they will never support WASM-GC. But then if you're shipping to, say, a web browser, you can have that WASM-GC support, which would be really nice. So yeah, I guess it's just finding a nice way to abstract that. So you can just use any GC. So yeah, WASM-GC is definitely very nice. I like how every browser supports it now, so thank you, browser people.
Yeah, that one was also kind of my question, but I'll state it in a slightly different way, which is, you're taking a garbage collected language and trying to represent it in C, and like there's definitely things that like some things will be easy, and then there's some things that will be extremely difficult in trying to do this type of transformation, right? So, like, how do you deal with things like long-lived objects, like things like linked lists and hash maps, and a lot of these things where like, garbage collected languages are easy, and then like if you try to put it in C, it's just going to completely break. Like how do I know for sure that the WASM file that I get out the other side is like, well-defined, and it's not going to have like, address sanitizer issues and all these types of things?
Yeah, I guess the nice thing is, so I didn't compile to C. I compiled to WebAssembly and then C. So I compile that WebAssembly to C directly rather than just compiling to C and then to WebAssembly. So just compiling to WebAssembly is like a IR, kind of gives you not a guarantee, but much better safety because you're not just compiling to like arbitrary C code. So it's like I guess like well-defined like what type of C it can output, which helps with, say, memory safety. But yeah, there is definitely some like memory allocation issues, which I think will be fine long term, but just a challenge.
All right. Thank you, everyone, for asking questions, and thanks a lot, Oliver, for this amazing presentation and the enlightening answers. And well, it's. Let's set up for the next talk. All right. While they prepare, I would like to mention it's an honor to present before you two of my really good friends and co-workers, TC39 delegates, and co-chair persons of WinterTC, as you'll learn. Andreu is a web platforms hacker at Igalia, Luca is a software engineer at Dino. They both are sort of veteran Dino contributors, which is fun, and they contain multitudes within them as the duo, the co-chairs of WinterTC, which is our fun name for TC55 of ECMA. They can do it all, but let's ask them what this whole thing is even about. So let's give a huge round of applause to Luca and Andreu.
Hi, thank you all. So today we're talking about WinterTC and about server-side JavaScript runtimes. You might have heard of WinterTC, or the Web Interpretable Runtimes Community Group, that was formed in 2002. This was
22.
2022. Sorry. This was a number of companies involved in server-side runtimes put together. Folks from Igalia, Node.js, Dino, like Cloudflare, and to formalize come to an agreement to have a subset of web APIs that should be part of the of every server-side runtime. And the goal in general is to make JavaScript runtimes JavaScript runtimes other than browsers more interoperable, and also to kind of it's more interoperable, reduce lock-in, so that you could write for one runtime and run in any runtime, and enable as much shared code between browser and server as it makes sense. And the idea is to avoid lock-in and expand the common baseline functionality. We started as a W3C community group. This allowed open collaboration without needing you to become a W3C member, which, for most companies, it requires paying membership dues, because obviously the W3C needs to make some money to fund their works. The thing is that due to IPR requirements in standards, and especially patterns are complicated and they're a mess. Community groups are designed for open collaboration, but they cannot publish technical reports or standards. They are designed so that they can eventually become something like a working group or a technical committee that can publish standards, but community groups by themselves cannot. So we decided that we needed to publish a standard. So we have the minimum common API that was initially prototyped as part of WinterTC, that defines the common baseline functionality, the things that we expect every server-side runtime to have. These are present in Node.js, in Dino. These are present in Cloudflare Workers, Bun. So it's things like URL, the crypto API, fetch, set timeout, readable stream, the works. So in the last Web Engines Hackfest, we had a breakout session about WinterTC, and we had started to discuss before that, but we eventually decided that we needed a new standardization venue where we could publish standards. So we quickly found two options. There was W3C working group and an ECMA technical committee. So it's WG versus TC. We had good discussions with both parties. The most straightforward option would have been W3C working group, because all of the legal machinery to go from a community group to a working group was already there. But there were things to consider, and the major points of interest for us would have been the invited expert policy, so folks who for folks who are experts on a subject matter or involved in the various matters that the standards are about. Like if they are not part of a member company that can pay member dues, or maybe they're an individual, maybe they're like freelance or working on an open source project by themselves, or part of a small company, whatever. There is an invited expert policy. This is part of W3C, this is part of ECMA, this is part of other standards, like other standards organization as well, I guess, so that they don't need to pay membership dues as an individual, or like maybe if it's a very small company, so that the very few individuals that like don't need to, like that small company doesn't need. Yeah, so we wanted to continue the open collaboration as much as possible given the circumstances. So we needed a good invited expert policy. We needed a simple organizational structure that wouldn't get in the way too much, but also organizational help so that the standards body could help us, and like, so it wouldn't get in the way, but it would also, like help us publish standards that would be recognized and so on. And yeah, so yeah, we decided to make it like this is the Dino blog post. WinterTC is now WinterTC, and it became ECMA Technical Committee number 55, or also known as WinterTC.
Yeah. So that happened in January this year, and we were obviously working on things prior to this, but as part of this, we really had to figure out what our charter is and like what we're actually working on. So what are we working on? One thing that we're working on is the minimum common API, which is like the subset of web APIs that we think every server-side JavaScript runtime should have. And I'll talk a little bit more about this in a second. As part of this, we also want to come up with a test suite, ideally reusing as many WPT tests as possible, because these are web APIs after all, to be able to measure like whether a runtime supports this this API, sort of like a conformance test suite. And then in addition to that, we're also thinking about standardizing additional APIs that are not relevant to servers directly, like a sockets API if we're talking over TCP and TLS, which is very necessary on servers to talk to databases and other services, but also things like a CLI API that allows you to do arbitrary file access, read environment variables, read process arguments, things like that. And these are like 3 different work streams inside of the technical committee. The main thing we're working on right now is the minimum common API. But there's also some other things that we're working on, which is figuring out how we can adapt web APIs like the fetch spec, for example, to work better in servers. I'll get more into that in a second. And then also we have some like server-driven use cases that are also useful for browsers. For example, streaming support in web crypto that we like wrote some specs for and are now working on upstreaming into the web crypto API in browsers directly. And those will hopefully ship both in servers and in browsers alike, and will sort of expand the common set for the benefit of both server and browser JavaScript people. So the minimum common API is a superset of the expose star web APIs. Some of you may have heard this. This is expose stars, like all the web APIs that are available in Shadow Realms. Will be available in Shadow Realms, maybe, who knows. These are mostly compute-only APIs, like URL or URL pattern, that do not involve any async I/O. And then in addition to those expose star APIs, there's also some general purpose I/O APIs that are not available in expose star, like fetch or set timeout. They're still generally useful across servers and browsers. And the way that we've chosen these so far is mostly based on like what do server-side runtimes already support. Like if out of two out of 3 runtimes, for example, support fetch, we'll include this in the minimum set. And this is sort of like a mixed bag of all kinds of I/O APIs. There's like 4 or 5 I/O APIs and like, I don't know, 20, 30 non-I/O compute APIs. But yeah, you can see the full list on the website. And in the future, we actually want to expand this a little bit more to also cover things like web GPU, off-screen canvas, image DOM-rec, things that are necessary to do graphics, because a lot of the APIs designed for GPU and browsers, like especially web GPU, also work incredibly well on servers. Especially the compute APIs, those are really useful if you're doing like AI things on the server, you need to talk directly to a GPU, and like there's an API for this. So why not also make it available on the server? But we don't really want to mandate that everybody needs to support graphics APIs, because not all servers have GPUs. So we're working on sort of targeted conformance levels as well, where we have the minimum common API, and then we have like a version of the minimum common API for things that support graphics, and like things that have a file system, and things that need to do HTTP. So we're probably going to split this up a bit more, and there's going to be some things that are like really the minimum common set, which is like, I don't know, the URL global or readable stream. And then certain parts of the I/O APIs will be split up further into specific conformance levels that runtimes can like pick from depending on what their target audience is. Yeah, one of the really most complicated things that we're working on is figuring out how to make fetch work on the server. Fetch is like, it looks like a really simple API, right? It's like an async function that you pass a URL to, and it returns a response, and you can do some things with the response. But like fetch is a very, very complicated spec. And really, all of the fetch spec is just like figuring out how to go from what the user tells you to what the underlying HTTP call is that you're going to do. Like the fetch spec does not specify how exactly you write the bytes onto a TCP socket to do an H1 request. But it tells you like what headers you need to put in, what things need to be sanitized out, origins, cookies, all these kinds of things. And a lot of those things are not really relevant on a server. Like on a server, you do not have a currently active page, which means that you don't have an origin, you don't have a cookie jar, you don't have a refer that you can make fetch calls from. And because of that, there's a lot of things that you don't really need to protect against. If you don't have cookies, you don't need to protect against leaking those cookies across origins. If you don't have a refer, there's no way to set a refer outbound header on a fetch call, right? So there's a bunch of things in the fetch spec that are just not relevant to servers. And identifying all of those and figuring out how to address that and how to ideally upstream into the fetch spec a system that allows servers to implement the fetch spec without all of these things is very difficult, and that's one thing we're working on. Another example of this is atomic redirect handling. I don't know how many of you know what this is, but in a browser, you cannot see redirects between like HTTP requests. When you make an HTTP request and it returns a redirect, that redirect is never exposed to the user. But if you're writing a proxy server, like it is very, very paramount that you can see that redirect request, because you need to proxy that redirect request to the user. So like things like this just are fundamentally against what a server needs to be able to do with a fetch request. So as an example of this, this is like all of the headers that Chrome sends on a outbound fetch call to example.com from example.com. You can see there's some headers here that are like overridable, which means that like a user can set their own things through the headers option bag. But a lot of these API, or a lot of these headers are things that are unforgeable, like they're unsettable by users. For example, all of the client hint things, or everything prefixed with sec-fetch. And a lot of these things are like, again, completely irrelevant to servers. Like servers don't have client hints. They don't, like, what is a mobile server versus a desktop server? They don't have a default language because it's usually not a user that's using them, but like a set of users. And they don't have multiple modes. They don't have like document fetch calls and image fetch calls and script fetch calls. They just have like fetch calls that you make with a fetch API. They don't have cores. They don't have origins. So a lot of the things, as you can see in the spec, don't really make sense for us. So we've been working for the past couple months on figuring out what like the initial required changes are to the fetch spec that we actually need to make this work well on servers. And we've been looking a lot at like previous implementations of fetch on the server in Dino, in Node, in Cloudflare Workers, and like figuring out what everybody has figured out by themselves so far is actually not useful. So I'll just run through this list real quick, allowing various anti-spoofing headers for outgoing requests. So things like the origin header and all the cores-related headers are not relevant on servers. All of the cookie-related headers actually need to be exposed to user code rather than being stripped out, because there's no cookie jar, so servers need to be able to deal with cookies themselves. Yeah, the third point is the same thing. the fetch has some handling of content encoding and content length that is like, I'm going to call it broken. Some people may argue with me on this, but this like completely breaks proxies, and it doesn't make sense in browsers either, really. It's just because you don't need to proxy requests on a server, or on a client, nobody ever notices things like this in a browser, that it's broken, because like the use case where it is broken just doesn't exist. And then like various options, such as like the window options in the fetch, the request init bag for fetch, like, makes no sense. Credentials, refer policy, all of those. And then like response types, such as opaque or opaque redirect, again, do not apply because we do not have to sanitize out specific responses because of their origin. And then there's some additional features that are never going to be relevant to browsers, but are very relevant to servers, like configuring the allowed protocols. You often need to do this if, for performance reasons, like in many cases, a local H1 connection is much faster than an H2 connection. You want to be able to programmatically say, like, this fetch request needs to use a certain TLS certificate for MTLS. You want to maybe programmatically configure that a request goes through a specific HTTP proxy. You want to set custom CA certificates because you're talking to like an internal service that has self-signed certificates. Or maybe you want to disable connection pooling for performance reasons. So we want to figure out like what a good single extension point is that servers can integrate with fetch for these things that will not conflict with something that browsers will do in the future as well. And how do we want to do this? Well, we don't want to fork the fetch spec, because the fetch spec is really complicated and it's already maintained by people that like know what they're doing. So we'd like to do this upstream, and we would love to discuss with you all how to best do this. We think that like a good way of doing this is starting on our side with like a high-level description of what actually is needed, like what needs to be changed, sort of like the slide 2 slides ago, and then working on some initially upstream maintenance work, like fixing bugs that we've encountered that maybe aren't relevant to browsers so much, but are relevant to servers, but that would also benefit browsers, and then making the spec more, cleaning up parts of the spec to make it easier to selectively ignore parts of it, like splitting up algorithms that are very large into smaller algorithms where you could like say, just ignore this part of the algorithm, or just ignore this algorithm entirely if you're on a server. And then investigate in the future whether it's feasible for the fetch spec to include sort of like a feature flag system of sorts, where you can say like, if you are on a server, don't do this branch. If you're on a browser, do this branch. Yeah, and this is going to take a long time, presumably, but yeah, we are very, very interested in doing this and like have the resources to go and contribute upstream. So anybody working on the fetch spec, please talk to us.
Yeah, so a standard is worth little without a test suite. And the web platform already has a test suite, which is WPT, the Web Platform Test. So in order to be able to test the minimum common API and the modifications to fetch that were, well, like the parts of fetch that we're going to support in the various, well, in the minimum common API level, we are currently identifying a subset of WPT that tests the minimum common API, including the subset of fetch that works with the things that we're identifying. And the thing is that this test suite obviously should only rely on the minimum common API. It should not rely on things that are outside of it, because this is the thing that, like this subset of the web platform is the APIs that should be supported in the runtimes, and like obviously the test suite shouldn't have, like ideally shouldn't have anything outside of that. So we sometimes need to modify tests, and as with fetch, we don't want to have a fork of WPT. We want to upstream our changes, and in some cases that means splitting tests so that one test has everything that like we can use in the common minimum API, and then a different test has the stuff that is only relevant to browsers. And for the additional levels that we mentioned earlier, on top of the minimum common API, like file system level, socket, servers level, and so on, we would actually add, well, for file system it depends, but CLI we would definitely have to add custom tests up on top, but it would be specific tests that we identify that would be on top of that. And if you are contributing to WPT, here's how you can make our life easier. Do not use, you shouldn't use document related APIs in tests unless, well, in some tests unless absolutely necessary. So, for example, if you, something that we were identifying in form data is that the constructor takes, the constructor has two optional parameters, which both are HTML elements. So in the minimum common API, we want to accept the constructor with no arguments, and then so maybe have one test file that tests it without any arguments, and then one that uses the HTML element at HTML form. So here in terms of file names, where you have a .html test, that's only in the that would be only in the main thread, and it's already going to require a DOM. I know that Dino and I think maybe Node run some of those tests, but we probably will not be including them in the minimum common API. So those are fine because they already kind of have a DOM. So if you're going to have a test that doesn't rely on, well, they have a document. If you are going to write a test that doesn't rely on anything that would not be that would be outside of the minimum common API, it would be best to have a .window.js or any.js tests, and those. For those, it would be better to not use any document-related APIs. And
just to be clear, this is really helpful for browsers too. Like if you have tests that rely on the document API, even though they don't need to, that means they don't run in workers and they don't run in service workers and they don't run in shared workers. And we have found multiple bugs so far in shipping browsers where they were exposing the wrong globals in workers and service workers, because they were not running some tests in workers and service workers because they were .html files. So in general, if you do not need to use document APIs for testing something, do not use document APIs. Make sure they run in workers and service workers too.
Yeah, so this is it. Our website of the WinterTC website is wintertc.org. Our GitHub, we had WinterTC still until last month. We finally changed to WinterTC 55. Just WinterTC or just TC 55 were taken. But yeah, we took what we could get. You can check out the minimum common API proposal. And we have, in WinterTC, we have meetings every 2 weeks at Thursday, 6:30 p.m. Central European time. Central European / Central European Summer Time. And you must be either an ECMA member or a TC55 invited expert to attend. So we've tried, in the open spirit of collaboration, although we need, these members need to be restricted to members and invited experts for IPR and pattern reasons, we have tried to make the onboarding process as easy as possible. It's just you open an issue in the admin repo. And so if you can become an invited expert that way and attend the meetings. So thank you, and that's all.
Thanks.
Thank you, Andreu and Luca. First of all, anyone in the room with questions? We already have another Sideshow Barker. Yes. Wait, who's next?
There's one right here, one over there.
Well, I'll go ahead and ask, since I can't believe that nobody's asking anything about fetch, but I'm not going to talk about fetch. But does it make sense for the minimum common API to have a structured storage or database API? Is that something y'all been thinking about?
Yes, we have. So there are actually multiple server-side runtimes that implement like either local storage or the caches API, or both. And there's multiple runtimes that have looked at whether to support IndexedDB. But the problem with the storage APIs that browsers have so far is that a lot of them do not work very well for server use cases. Like local storage, for example, is synchronous only, which like is, you don't really want to block the event loop in servers, like much less than you want to do that in browsers. And IndexedDB is like incredibly complicated for what it provides. So yeah, maybe if we can sort of collectively come up with a new storage API for the web. I know there was the KV storage proposal a while ago. Yeah, exactly, WebSQL. Absolutely, we would totally do WebSQL. Like, I think all of the server-side runtimes that I know of already ship SQLite locally in their binary. So let's just expose it. Yeah, but then also things like the cache API, for example, there's like stuff in there that makes sense in a browser, like listing all the things in the cache, that if you want to back this by like a distributed cache on a server, does not make sense to list all the items in the cache, right? Like that's not a supported operation of most cache services. So we sort of need to adapt those a little bit for them to work well.
Yeah, I just have a question about given that we have been shifting from WTC community group to a technical group, I'm wondering that if there are any commitment from the previous participation runtimes that there will still be a member of this TC and they will still be committing to adhere to the new standard so that this can be actually
Sure.
the standard.
Yeah, so I mean, we haven't actually published any standard yet. So there's, oh, please, well, don't fall, please. We haven't actually published any standards, so there's nothing to actually adhere to right now. But like Dino and Cloudflare will adhere to the standard when we publish it, and Node probably will. Like with Node, it's always a bit difficult because it has to go through the technical steering committee.
It will adhere to some there are some things where Node.js, due to legacy reasons, is not 100% aligned with the web specs for a long time, and we don't see that changing, and we are not planning to allow that in the minimum common API. But this is one thing that we know where Node will not implement those parts of the standard, and but that's because they cannot because of legacy constraints, and that they will implement as much as possible.
Yeah, and one thing that we have done is make sure that everybody who's contributed to the W3C community group has the ability to join the TC meetings. So either because they're already members in ECMA or through becoming an invited expert. So we didn't we made sure that nobody was lost along the way while going from the community group to the TC.
Yeah, and in fact we chose part of why we chose ECMA is because a lot of the members of the community group were members of ECMA, and not so many were members of W3C. So that was a point in favor of ECMA.
I'm curious to hear a bit more about the test suite that you're working on. In particular, are there any tools that web platform test authors can use to help ensure that they adhere to that minimum set? Like, for example, are there any of the participating runtimes, do they have a WPT test runner or glue or anything like that?
Yeah, so that's a fantastic question. And the answer is yes, but it's not integrated into WPT.py. So both Dino and Node run WPTs. Let me see if I can open them here. Is it going to load? Okay, it's not loading. Well, just believe me, they run. Oh, there we go. Okay. So let's open, I don't know, like compression. There's obviously like a lot of tests here that don't run because we don't have service workers in Node or Dino, but you can, after you've written your tests by the next morning, there should be results on wpt.fyi, but we don't run them as part of the WPT test or like suite as browsers do right now.
And well, there were some. We were thinking about making like ways to make this easier, but this is still under discussion. And,
yeah, like we are actively interested in getting Dino and Node into wpt.py so that you can run them locally. It's just really difficult, unfortunately. Philip.
Are you actively converting these .html tests to .any.js tests? Because I think in my experience there are actually a lot of tests that could depend only on the minimum common API that require loading an HTML page.
Sorry, can you repeat that?
So in my experience, there are a lot of tests that could only depend on the minimum common API that actually require loading an HTML page. And I'm wondering if you are actively converting these?
Yes, we are. We've converted like, I don't know how many, but like hundreds of tests at this point from .html to any.js. And like, what are you looking for?
I'm trying to find the slides.
Oh, they're up there.
Right.
Yeah, so we have done like hundreds of these, and we'll do more. Like, yeah, this is actively something we're working on.
Could you go back to the slide around the common API? I just have a general question about this, but there seems to be a trend towards moving more and more of these APIs from like the general browser into workers and stuff. And I'm wondering where you see this, if you see this trend over the next few years. I know there's, for example, open issues about like adding DOM to workers so that people can like work on DOM trees. Event target is, I think, in Dino, it's actually quite a useful API for servers. So, like, I don't think this is a good idea, but I'm just curious about like devil's advocate. Like, what about just shipping all of DOM into the web runtime? Like, what is the kind of trade-offs there? And that's one of my questions, if you want to.
Okay. Yeah. Do you want to go ahead?
Yeah. So obviously, there's a lot of complexity with shipping all of the DOM. There's the HTML parsing. There's a lot of APIs, a lot of complexity in various different. I don't know. Would you want to support shadow DOM in the server in the server side? I see, I think there's a lot of complexity, and but there seems to be a significant use case. So it's like, it depends. We were recently discussing a bit of this, I think, in the last meeting, because someone brought it up. I wouldn't see that in the minimum common API, but maybe possibly in one of the levels that sit on top of that.
Yeah. I think specifically certain APIs are really useful. One thing that's really annoying with web components is server-side rendering, because the way they're invoked just makes it really difficult to do on a server. If you have enough of the DOM to be able to server-side render web components, that would be really useful. So that would be a good, useful subset. But I don't know, the regular canvas API, if you're not going to be displaying anything anyway, there's no point in painting to a canvas that you then don't see, right?
Well, there is a very common use case, which is to render a DOM tree so that you can capture capture a screenshot of it effectively. Mm-hmm. And so loads of websites like GitHub's social graph images, it's just like Chromium kicks up a browser to render an SVG and capture a screenshot. So I can imagine that kind of thing in a worker or a WinterTC context. The other question I had is just a concern I wonder if you have had the same concern, and I wonder if there's ways to address it around this kind of bifurcation of the APIs and the complexity that burden on the developer, understanding that like, yes, we can all understand that, you know, we're going to shoehorn this bit of the algorithm into another bit that gets optionally run, but like, what kind of complexity does that expose to the developer to understand that this fetch algorithm is going to be substantially different on a runtime versus DOM or worker or something like that?
I don't expect that there would be my understanding, my feeling is that in the inline node, developers don't really notice any anything different to the web, and if they do, it's things that make sense considering the differences.
Yeah, right? I think like a major part of this is that a lot of the things we're stripping out are things that like generally people on the web run into as like annoyances with a fetch spec. Like nobody really wants to deal with cores, right? It's like an unnecessary evil that you have to do because you're working on a browser, and those things not existing is like, it's nice. You don't have to deal with cores, right? But I think the biggest thing is that like the API 99% of use cases works and looks exactly the same. There's like a few edge cases that are different, and those obviously need to be documented. But for the majority of use cases, it's like you can run the same code in the browser and the server, and it'll just work.
Right. Thank you. I know that we're super excited and want to ask more questions, but this discussion's eating into the break, and I'd rather be the one.
Yes. Yes.
Thank you. I'd rather do the eating myself, so let's break, but we could ask questions over the break. Yeah, see you all at the hallway track, and a final round of applause for Luca and Andreu.
Thank you.
just last year. Early last year, I think. It's the better. Yes. Hello? If folks outside can hear me, now's the time to finish up and enter. Hi. Oh, there's a few of us here. I guess we can have fun and you snooze, you lose, that kind of stuff. Should we? Well, maybe let's give a couple of minutes. Until then, we can, I don't know, have a chat, play Jeopardy. What do you want? American history for $200? Open source? No. Okay, well.
I mean, it says there.
Oh, yeah, I should. What is JSR? But quite literally, what is JSR?
Well, we'll find out.
We'll find out. By a show of hands, how many of you already know about JSR? Okay. We're definitely outliers here.
Yes.
No. Have you used JSR already in the past? Wow. Okay.
It's the same people.
It's the same. Well, I'm in the set of people who know but haven't used it. So,
so even more outlier.
Yeah. Good question. If Leo stopped working on it, then.
What?
All right. Well, might as well, right?
I guess. I don't know. You're the MC.
Yes.
You lead.
Okay, let's start. It's been 5 minutes. Thank you, everyone, especially as the set of people who managed to listen to the talks instead of have a fun chat outside, which is definitely not fun. The next speaker is Leo, also one of my friends, and a huge fan of metal music. I would like to attend a concert, or a baby metal concert with Leo, but I don't think I'll make it to the end, so I'm not allowed to. They're a software engineer at Dino, a prolific contributor, and have been working since last year, maybe earlier than last year, who knows, on JSR, this amazing new registry that they've been building. I got a sneak peek of it at FOSDEM early last year, and they announced it shortly afterwards. Since then, the last year, they've been sort of tightening the loose ends and working on it. So let's hear it from Leo.
Yeah, hello. This is JSR. So, in this talk about JSR specifically, first gonna do a quick overview, and then also more into the behind the scenes, how it works, and how more runtimes can implement support for it. So first, what is JSR? JSR is a modern JavaScript registry, so similar to NPM, you can imagine, but it does not replace NPM. It works on top of it, but in addition, it adds many new features. For example, support for TypeScript out of the box. You don't need to do all the typing, like transpiling yourself. It's all done automatically by JSR. It's compatible across all the different runtimes, be it Dino, Node, Cloudflare Workers, Bun, you name it, as long as it supports Node modules directories. And it's completely open source and free, unlike NPM. And it has built-in support by Yarn and PNPM nowadays as well, but not NPM. We'll get into that. First off, why did we build JSR? Well, publishing to NPM is a bit complicated nowadays. Who has tried to publish to NPM and has struggled quite hardly because of like TypeScript or other setup stuff? Okay, some. Yeah, it's a pain, let's be honest. If you want to use TypeScript, first you have to set up all the TypeScript config, make sure that works correctly, the correct target, etc., and it's just way too difficult, and it doesn't need to be that way. I mean, why can't we just publish TypeScript and have the runtime still be able to use whatever the registry provides? And, well, that's what we tried to do. We basically transpile the TypeScript on the server. We provide all the script types, like all the JavaScript and DTS files separately including also the source maps. So like, we do everything for you. You don't have to do anything yourself. And NPM stopped innovating. Again, the JavaScript ecosystem is known for rapid movement in, like, we get a new front-end framework like every week. I don't know. I don't know how many there are at this point. It's too many. But it moves fast. But NPM doesn't move at all, which is quite not how things should be, given that it is such a big ecosystem that does evolve quite fast. And then our values are, unlike NPM, which is owned by Microsoft, we are completely open. Asterisk, we'll get to that in a second as well. But yeah, it's open source, community, and open governance are core principles. We'll see more details into the governance in a second. And then some additional features are tokenless auth. You can just publish from GitHub CI without having to set up tokens, etc. It's all done using OIDC tokens. Provenance, we can give provenance attestations to just prove that the person that published a package actually is the person that it says it is. And then we auto-generate also documentation for all packages based on the exported function definitions, typings, JS docs. And that just makes an overall more grounded experience for users. Because, I mean, when you go to NPM, you try to find a package, you find a package, and then you have to dig through documentation. And half of the time, the package doesn't have documentation, or it's like completely out of date. It doesn't need to be that way. So we generated documentation for you. So, the governance. First off, why is JS open? JavaScript is not controlled by a company, but by a committee. JavaScript implementations are open source, like V8, JS Core, etc. And NPM is closed source. The community could not innovate at all. I mean, the NPM CLI is open source, but that's not NPM itself. It's just the CLI to talk with it. So JavaScript's registry needs to be open source, governed by the community and open to innovation, just like everything else in the JavaScript ecosystem. So the board members for JSR are Evan Yu, the creator of Vue.js and Vite and founder of Void Zero, Isaac Schluter, the creator of NPM and co-founder of VLT, James Snell, Node.js TSC member and principal system engineer at Cloudflare, Luca, software engineer at Dino and T39 representative, who we saw earlier speak, and then Ryan Dole, the creator of Node.js and Dino. So these are our board members for the governance group. We add more if necessary or if there's people that are interested, but currently these are the 5 that we started off with. And we have had some board meetings already for which all the notes are published to GitHub. So what does the board even do? It oversees JSR's movement to a foundation. So currently JSR is not in a foundation. That's why the asterisk earlier. It's currently still part of the Dino company, but the whole goal of JSR is that it's open. So we are currently trying to move it under a foundation. We've had talks with OpenJS, ECMA, and a few other ones, and most of them are interested in being able to host JSR, but it's a slow process. It's not something that goes quite quickly. So we'll see exactly also which of these organizations we go along. Maybe we also go with just creating our own foundation. We'll see. So by the way, the QR code is a link to the charter. So if you want to take a look at the charter, you can see that. And then it also sets the general direction of the project, making decisions on behalf of the project when necessary. This is quite rarely that this is going to be the case, but it is something that will be done if necessary. Determining how governance board is elected in the future. So again, adding new members, how will that exactly be? It's not exactly clear yet, but also we have a good set of members for now. We don't seem necessarily need more, but if there's people interested, we'll see to add. And then determining how to review open source contributions to a project. So currently we don't really have much of a policy for anything. I just decide basically on a whim if a PR should go in or not. And it's obviously works for most projects like that, but having also a more stricter policy on how open source contributions should be accepted and if we have any additional policies around that, would be good to have. Then, additionally, we have a moderation group. Moderation group is Oliver Medhurst, so the creator of Pro4, who we saw earlier, Augustine Morey, who is a contributor to Node.js, and then we have Dr./Bacchus Light, who is a contributor to JSR and Dino for a long time. And the moderation group basically takes care of any of the moderation, so be it support from users, so we have a ticketing system in JSR, or if there's any conflicts, like someone is wanting to have has a scope that someone else wants. So it's more about moderating the actual ecosystem of the JSR, all the JSR packages. And we started with these three because it's people we know, but we will expand. The QR code in this case will go through the run book, is what we call, which is basically the policies mostly we follow for doing moderation. It's not set in stone. It's relatively flexible that we move and adjust for giving as much flexibility and usage for the users and not have to moderate too strictly, because, I mean, it's an open source project. People should be able to do as much as they can as it's reasonable. Then, behind the scenes of JSR and how it works. So, the CLI and publishing. So, first off, JSR has a configuration file, similar to package.json, which is, contains the name, the version, the license, and an export, which in this case is a string, but it can also be an object. So it's not too different from package.json, but it has some differences, and we don't want necessarily to, if we want to add more things to the config file, and then there's going to be conflicts with package.json, we decide that we rather have our own config file. However, let's see, the publishing flow is this graph basically. So basically there is auth without using any tokens. Basically the CLI makes a request to get a code from the server. The code is basically a random generated code that is just identifiable for like a few minutes. The server then just stores this in its database and then gives it to the CLI, and the CLI basically just prints out a nice URL. You can click on it, and then you get a prompt in the browser that will say, yes, I want to give this device, aka the CLI, permission to interact on my behalf, or no, I don't want to do this. And in the case of yes, it will then start to do a publish. So if the directory is a workspace, then it will basically get a list of, or generate a graph of all the members of the workspace. So it will see which workspace members depend on other workspace members, and it will order them in such a way that it can publish them all in order and also concurrently as much as possible. So if you have like a workspace member that depends on one other workspace member, but there's 5 others that also depend on this one, it will publish all the 6 top ones that depend on the singular one at the same time, because why not? And then, yeah, once we know if we have workspaces or not, we will generate a table for the entire directory. So we upload every file except stuff that's mentioned in the git ignore. And then it's uploaded to the server. And then the server adds a job to queue the process of the table, which is validate if it's actually valid, that the configuration is set correctly, that there is files that are allowed, the file size is what's supposed to be the names of the package that's being published to, and the name and the config file being correct, etc., etc. There's a bunch of things that are being validated. Then it analyzes the motor graph and checks for slope types. Slope types is something that we kind of started. I'm not sure, can't remember exactly what the name in TypeScript is, the equivalent, but basically is we don't want people to publish types of public API that does not have full concrete types. For example, returning a function while leaving to inference what the return type of the function is. We give penalty to user for publishing that. We still let you publish, but we'd rather not, because TypeScript is not fast, as we all know, and it's computing the the inference of the types of like return functions can sometimes be extremely computational expensive, especially on your LSP, and then sometimes you have to wait like a decent amount for it to just compute, and it's just not good. So as an enforcement, we try to have people publish the typings to have also return types and any other stuff that can be inferred that we'd rather not. Then we create an NPM table. So it split the TS files into JS and DTS files and converts JSX to NTSX to JS and all the other fun stuff like that that you would have to do manually yourself. And then that's just stored as a table in the registry, and then NPM can fetch that. We'll see that in a second as well. And then it generates documentation information from the typings and the JS doc comments, and then it's published. So how do package managers work with JSR? So for NPM-compatible clients, we have npm.jsr.io. It's not going to load. It's a blank page. If you try to load it in your browser, it's just a service that implements the NPM registry API. Basically, NPM has then writes registry setup for if like companies want to have internal NPM registries, and we just reuse that. And then if you use NPM to download the packages, you need to add a .npmrc and specify the registry, aka being npm.jsr.io, to be a prefix for any packages that start with @JSR. And the JSR CLI does it for you if you try to use the JSR CLI to add dependencies. However, then there's Yarn, PMPM, and VLT. They all understand JSR specifiers in the dependencies field in the package.json. So you don't actually have to set anything up. You don't have to use the JSR CLI. You can just use those tools as you want, and they internally point to the JSR NPM registry, and it's all abstracted away from the users. And Dino just gets the sources directly. We'll see exactly how that works in a second. But yeah, Dino does not need to download the entire table. It just downloads the files that are necessary. So the module loading is that we currently discover all the JSR specifiers before we start resolving them. Then we will also get the meta.json file, which contains the information about the versions available in the package and the latest version, and also files in those versions, etc., to do some resolution. Because the whole point of JSR also is that it's Semver compatible. That's why we're not just doing plain HTTPS imports. You can do Semver deduplication. That's one of the key reasons why we started JSR in comparison to what we had previously for Dino, which was just a HTTPS registry where people could just upload their files, which works, but it gives a lot of problems for if you have like multiple versions of React, which is quite common. And now we can actually deduplicate that with JSR in comparison to our old system. And then it will get the meta file for the specific version, which contains the package manifest, the exports, and module graph for all the entry points. And then we get the requested entry point by the user and any of its dependencies through just simple, regular HTTP or HTTPS imports. So JSR specifiers technically are just a nice redirect pretty much to actually just a HTTPS import, which has also the capabilities of doing Semver deduplication. And then it just loads the files. It's just like any other import. So yeah, what's next? So we're going to continue trying to get JSR on the foundation. I mean, it's more of a matter of time and slow processes by these organizations, then see that the NPM CLI adds native support for JSR. We don't know if that will happen. We'll see, we hope. I mean, if enough people complain, they probably will. And then allow browsers to import JSR packages via HTTPS. We currently don't allow that directly, just because we currently don't want to get burdened by the costs of serving browsers, and that's gonna not be nice. So once we move to a foundation, we will have Cloudflare most likely backing us to some degree, and they have a whole system in place for foundations and open projects to have to use the infrastructure for free. So then we would be using Cloudflare's CDNs, and they would cover all the costs of that. So then we would make HTTPS imports in browsers available for JSR, and then get popular NPM packages moved over to JSR. I know already a couple of package developers on NPM that have really popular packages that, I mean, they use NPM, but they would prefer to use JSR. And the main blocker until now was, well, you have to use this npm-rc, it's not nice, and then you publish to JSR, and then currently there was no, or before there was no way to depend on JSR packages npm, but this is all solved now with the native yarn npm support. So you can actually publish npm packages that depend on JSR, as long as you don't use the npm CLI. So yeah, we'll see exactly how the future of JSR goes forward, and if more projects switch over to JSR. I mean, there's interest being put by big projects, but we'll see how it actually plays out. So thank you.
Thank you, Luke. Leo, do we have any questions in the audience?
I have a bit less technical question about the popular packages moving from NPM. About the popular packages that you plan to move from NPM and encourage developers. Did you think about the problem of squatting the names of the packages? Because actually, currently, technically, as I see, it's possible to squat some names of the popular packages in JSR, and it will be just, can be used as a malicious, with malicious intentions.
Yeah, so that's a good point. We do have a list of the, I think we grabbed the 500 most popular NPM packages and scopes, and we have just a JSON file that has a reserved list of scopes, and people cannot register those scopes. Now, additionally to that, we also are, unlike NPM, we are responsive to users and companies and other projects trying to do things. Like I heard yesterday about someone trying to have a package on NPM, and they've been going on for 2 years with the NPM support about getting this package, for which they already have the original GitHub repo, but NPM refuses to transfer the package over, which is stupid. And Dino had a similar problem as well for a long time. So we are more responsive to those kinds of support scenarios where if there is a project, let's say TensorFlow, for example, and someone grabbed the TensorFlow scope. Well, if TensorFlow comes to us and says, hey, someone has the scope of us, and then, yeah, we'll just transfer it over then. I mean, first we're going to obviously reach out to the original creators of that scope to see why they have it and if they actually be willing to transfer it, because we're not just going to do it without any permission. But usually it ends up working out, and if it doesn't work out, then that obviously escalates the situation, and we'll see from there. But so far, everything has worked out, and if the author doesn't reply, then we just make it based on our own, like on the runbook, and also on just having our own decision-making on, does this make sense to give? I mean, if someone takes TensorFlow, I would just say, give it to TensorFlow people.
Yeah, thanks for your presentation. Can you talk more about WebAssembly support, or like about if I wanted to publish a WASM module onto JSR, how's this going to work with things like the module loader? Am I going to be able to get support for things like ESM ahead of time? Maybe that would be very cool. WASM ESM. And like, you know, in general, like if I have a DTS file that's backed by like a WASM file, which of course I do, does JSR make my life easier relative to what I can do on NPM?
I mean, JSR does support WASM files without a problem. Static inputs of WASM work. It also generates documentation for those WASM files. So if you go to the docs, I mean, I can actually quickly pull up the JSR website. We can go to a random package, and I can quickly show the docs. Oh God, there we go. Like we have the automated generation of documentation, and it will also, like if there's a WASM file in this package, let's say, this would also show up here. We do generate documentation also for any WASM files. And if there's an accompanied DTS file, it should just work. If it doesn't, it's a bug, and you can complain to Luca.
Hello, here in the far
Yes.
behind. Yeah, thank you for the presentation. I fully agree with your problem statement. But in the end, NPM may be owned by Microsoft, but there's some friendly Microsofties behind that massive corporation who actually run it. So the question is, has there been any effort at all in maybe talking to those Microsofties and seeing if there is any interest in converting NPM to more of an open government structure?
I don't know. Luca? Mike?
Okay, that's interesting.
Luca knows, so.
Thank you. Yeah, so I have talked to multiple people at Microsoft, and the general consensus is that it is a project that is too big and too complicated to open source, like the server side of. And yeah, let's talk about this like on the hallway, because some things that I don't want to say it out loud on YouTube.
As a package author, one of the blockers for me until finally starting to publish on JSR was the mismatch between what I was doing publishing for NPM in sources versus on JSR and for Dino. In particular, the support for TypeScript, the import from .ts and that. And right now, what I'm noticing as I'm publishing things, I need to, when doing a release, I need to update both my package.json and my JSR.jsonc files. And there's a little bit of a mismatch like this, and I'm sure there's other little stumbling blocks like this. Do you have a plan for increasing the ease of use of being able to, for example, as a simple thing here, being able to refer somehow in a JSR.jsonc to saying, look at package.json for my version file, rather than requiring the same number to be repeated in multiple places, and other information like this?
So funnily enough, we had, so we have an open meeting every 2 weeks, and last open meeting, aka 4 days ago, we actually discussed exactly that. And the consensus was, no, we don't want to infer the version from package.json, because there is many projects that want to version it maybe independently, which is kind of weird, but additionally also is just, we don't necessarily want to infer stuff from the package.json because it's not a format we are in control with, which, I mean, this is a big discussion that can be going to the hallway later also, but in the end, we agreed upon that we will just prompt, like give a warning that yes, the version mismatch is there if the package.json has a version that's different than the JSR.json. But for information, you can, when you do like a JSR publish, there's a version flag. So you can specify the version via command line flag. So in your CI system, you could just refer it. But yeah, there's a lot of paper cuts like this. And I mean, in the end, we have an issue tracker with a couple of open issues. So we'll definitely have many things we need to improve on and stuff like that. And like what I just described is not like a final decision that we will not change. It's just what we agreed on for the current time for fastest resolution.
All right.
Sorry, quick last question, maybe not quick. Yeah, I'm pretty excited about the fact that we can publish TypeScript to the registry natively, but I can also see the tension here that there are past incompatibility between TypeScript and the ECMAScript, like on the class field, and there were breaking change in TypeScript. So what if there are breaking change in TypeScript in the future, and we have TypeScript already being published to the JSR, and I'm wondering how will JSR handle this situation?
Can you pass the mic behind you? There's an answer.
Yes. So that specifically is, the answer to that is that so Dino has been doing like executing TypeScript for like 7 years now. And there's so far been one case where like there was a change to TypeScript in the emit output that was in any way breaking. And that broke like very, very small number of packages. And like the TypeScript team generally does not break the emit output, even especially for old features. So whether you emit for these old features or not is like primarily a question of do you want to or not, and not like is there any stability guarantees associated with it. Like they do not break old features generally.
All right. Was that it? Thank you. Well, you can find Leo around at the Hackfest itself or at the after Hackfest activities. But that's it for today, and let's move on to the next presentation. But before that, Leo. Okay. For our next speaker, she's been a friend, colleague, teammate, one of the most, how do I say, you might associate her with her work on Node.js. She's done some pretty exciting and popular things throughout the years on VM, on V8. She's a V8 contributor, and one of our new neighbors here in Coruña. So please join me in welcoming on stage Joyee. All right. From what I understand, Joyee is a huge fan of museums and maintains a definitive tier list of all of them. And yeah, if that's something you're interested in, feel free to ask her. I think she's more than happy to give recommendations and tell you which ones are not good enough. All right, bridging the CommonJS, bridging the gap, I guess, with CommonJS and ESM. Another round of applause for Joyee.
Thank you. Is it working?
Yeah.
Okay. So hi everyone. Today I'm going to talk about bridging the gap between CommonJS and ESM in Node. So quick self-introduction. I work at Italia, as said before. I've been sponsored by Bloomberg on my work in Node. I'm a member of the Node Technical Steering Committee and the VA committer. You can find me on GitHub via the handle Joyee. Now, since we're at the Web Hackfest, maybe not everyone here is familiar with Node, so I would like to give a heads up that this talk will contain some technical details from Node, but it is also more of a story about how we move this ecosystem forward by providing a path with non-breaking incremental changes. Something that also need to be done quite frequently among web engine implementers, because as we've also learned in the past 5 years, asking everyone in the huge ecosystem to make breaking changes to migrate is not effective, which I'll touch on later. It's also a story about how we experimented changes in a subsystem heavily relied upon by a big ecosystem, where every change can be a breaking change. I took this meme from XKCD, where someone fixes a bug to make the CPU not overheat, which ends up breaking someone's obscure workflow that interprets a temperature rise as a control. Things similar to this happen to Node quite often. Node uses Simver, but since it also prioritizes stability, it also resembles the web in terms of having to avoid high impact breaking changes. But what if every change is a breaking change? How do we minimize the impact? We'll get to that later. So let's start with a brief history of ESM in Node and see how we got to where changes were needed. Node was created in 2008, and in 2009, it added support for a module system proposed as part of CommonJS. in 2015, JavaScript got a new standardized module format, which is generally called ESM these days. A group of contributors started the design and development of ESM support in Node from 2015, but it took a very long time. And there were a lot of debates around the interoperability between the existing CommonJS module system and the new ESM system. So after about 2 years of discussion, in 2017, the initial implementation was finally released in 8.5. Then there were like 2 more years of debates and collaboration. The design was kind of changed multiple times. Finally, the support for ESM was unflagged in 2019 and stabilized in 2020. So that was about 5 years ago. When ESM support finally reached stability in Node, it already supported importing CommonJS from ESM. Like here, you can import the module.exports object from CommonJS into ESM as the default export, like the logger here. You can also import ning exports from CommonJS into ESM, which are detected using static analysis that work with common export patterns, like the log function being assigned to module.exports as a property here. And in ESM, in Node, require is not available as a context global. So if you have to load CommonJS dynamically from ESM, you have to create your own require in the module. And when you import a path from ESM in Node, unlike require, you have to specify the file extension. It does not support resolving from directories. There was also support for things like top-level weight, dynamic import, and more specific things about ESM at the point. But for the context of this talk, these are the most important ones. On the other hand, in the existing CommonJS, which was the vast majority of the Node code in the ecosystem at that point, there was only very limited support for loading ESM. You could not require a ESM in CommonJS. Dynamic import works, but it returns the promise. So it can only be used in asynchronous paths. So at that time, CommonJS could not load ESM without coloring the whole dependency graph async. But the majority of the ecosystem still run effectively on CJS. So some packages wanted to use ESM without breaking users and losing popularity. So they started to invent all sorts of workarounds. One of the very popular choice was to transpile ESM to CommonJS. And these are called full ESM. But this caused a new problem. So when the transpilation was done somewhat magically by tools or frameworks, developers see their code as ESM, but Node only sees CJS. So then when the transpile code loads real external ESN dependencies, developers will start to see error require ESN from their code written in the ESN format, which will be very confusing. If you search for error require ESN on the internet, you can see a lot of people struggling with this. This also creates a ripple effect. The more code in the while are run in CommonJS via transpilation, the more users and transitive dependencies also have to stick to CommonJS as a execution format. So another workaround that packages do was to ship both. The supply CommonJS to CommonJS, ESM to ESM. And one of the most obvious side effects of this is that it doubles the size of Node modules. So yeah, this just doubled. So apart from the duplication, dual packages are difficult to get right. For example, if you have an ESN consumer that loads 2 different dependencies, like here, A has one CommonJS dependency B, and another one is in ESN D, and they both in turn load the same package C via different path. Well, then you end up with 2 versions of the same package in the same graph, and not every package is set up correctly to expect 2 versions of itself in the same graph. This can lead to some very tricky bugs. And all this actually demotivate the adoption of ESM. So Titus has this nice tool that surveys the module types of the top high-impact NPM packages periodically. I took the data from there, and as you can see, many package authors chose to ship both CommonJS and ESM to maximize compatibility, that is labeled dual here, or they chose to ship transpile CommonJS, which are labeled full here. And after 5 years, since ESM stabilizing Node, only about 11% are shipping Brio ESM. The others either ship CommonJS or some form of CommonJS. And as you can tell, the growth of ESM wasn't particularly fast. And after all these years, more packages were actually inclined to ship dual instead. Now, for package maintainers, they either they enter a pick your poison situation. Either they ship ESM only and lose popularity among users, since most people are still effectively running CommonJS, no matter it's transpiled or not. Or if they ship CommonJS, they might run into issues with their own dependencies that migrate to ESM. If they ship transpile ESM or dual ESM, the setup can be difficult and annoying. In the case of dual packages, it's also difficult to get right and increases the size of the distribution. Now, what if require ESN gets supported? Most of these problems would just go away. Like full ESN and dual packages would no longer be necessary. It will only become a choice between ESN and CommonJS, and it's up to the preference of the package author. And most authors these days prefer to write ESM for new code anyway. It would be much nicer for them to just ship what they write directly. And users can do incremental upgrades for different parts of the code base instead of having to go into a all or nothing situation. Well, then why wasn't required ESN supported in the first place? Well, first of all, not that many people knew that it could be done. Those who did gave it a try in 2019, but they didn't pursue it further after some technical debates and challenges. And then we had this misleading documentation saying that ESN are async, therefore cannot be required, even though in the spec, ESN is only async when it contains tuple weight. And most people who were not involved in ESN, like myself before, kind of just believed what the documentation said. So time went by and people stopped trying. And then many years later, I happened to look into the ESN implementation in VA because I was investigating a memory leak. And I noticed that the implementation, which follow the specification almost to the letter, can resolve the evaluation synchronously if the module does not contain tuple weight. And then I confirmed this later with people who worked on the specifications, like Little Dan, who wrote those lines, that this was intentional. And this semantics was also relied on by bundlers. So this means, as a host, Node can implement something like this. This is pseudocode. In reality, this needs access to native V APIs, but the gist of this is to implement require ESM, we can just fetch the module graph and link them synchronously first. That part is up to the host, so we can make it synchronous. And then we can check if it contains top level weight. If it does, we throw and say it's not supported. Otherwise, we evaluate the module synchronously. And the specification guarantees that at this point, because it has no top level weight, the evaluation of a synchronous module should finish synchronously. And we can just return the namespace to the user with evaluated values. And this check actually is not a novel concept. For example, service workers also disallows asynchronous module graphs. That the Proficiency specification also says something like, if the module is async, it should fail. This even saved us from having to add an API to VA to check if the module graph is asynchronous, because it was already added in VA for Chrome to implement this for service workers back in 2020. The specification side had also been brought up in early attempts of require ESM in Node back in 2019, but somehow the work didn't get done. So I learned about all this in 2023, and I discussed with other contributors about implementing require ESM. The problem was, though, if we go back to this pseudocode, you can see for this to work, we need a way to fetch the source code and link the static module graph synchronously. But in 2023, The ESM loader in Node has like self-imposed asynchronous code everywhere. And underneath it was like 3,000 lines of code that I had barely read before. So I thought, okay, I'll leave it to other people who are more familiar with it to refactor, because module wasn't really my jam. So an issue was open to call for help to refactor out all the promises from the module loader, and I moved on to work on other things. So a few months later, I was working on the compile cache, and I ended up refactoring the compilation part of the ESM loader, and I reading the code a bit more. And I realized maybe instead of refactoring that 3,000 lines, it would be easier to just write a new synchronous and trim down ESM loading path for require. I could already see it in my head. I know lines added would be easier to backport than lines changed. So this felt pretty promising. I also got support from Bloomberg to work on this. So I started working. So I prototyped it a bit. I asked other contributors first to test the temperature in the room because I wasn't really sure back then. And I opened the pull request, and the reaction was very positive. So no one was saying that this should not happen. It was just lacking volunteer to actually do the work. So there were some edges that needed more work, but we agreed that those can be follow-ups. And nothing comes up perfect at the first try anyway. We can always iterate while it is behind the flag. So I added more tests and fixed more bugs, and I got this pull request landed. But landing the first pull request was just the beginning, and that turned out to be the easiest part because there are already a lot of user-land conventions and workarounds for the lack of require ESM. So we need to make the built-in version work with those. In the following month, I got a lot of help from contributors and package maintainers to test it out on the packages in the ecosystem, and we'll work on more features to improve interoperability while trying not to step on the toes of the existing code in the ecosystem. So here is the release and support schedule of Node. If require ESM ends up having any high impact breaking behavior and have to be similar major, then the last LTS that doesn't support it by default will be 22 or even 24. Then package authors would need to wait until their end of life to start transition. That would be 2027 or 2029. But if we can keep it non-breaking and similar minor, we can backport this to older LTS, and package maintainers can start migration a lot sooner. It could be a 4-year difference in the timeline. So that's why we have to kind of minimize the ecosystem impact of this and make it as non-breaking as possible to make it back portable. So the first thing we needed to figure out was, does the lack of support of top-level way matter? To understand the impact of the ecosystem, I wrote a few scripts to analyze the high-impact packages. It comes down to basically just try requiring all the packages and see if they fail. If they fail, just analyze the reasons. We tested on the top 5,000 high-impact packages on NPM. More than 400 of them are dual, and more than 500 of them are full ESM packages, which already don't use top-level way anyway because it's not supported in those formats. About 500 of them are real ESM, so let's break it down. It turns out that among the real ESM packages, only 6 uses top-level way. 3 are waiting on FS APIs that have synchronous counterparts, and they were using the synchronous version before they got converted to ESM anyway. 2 are awaiting a dynamic import of Node buildings in case they are not running on Node. So we added process.built-in module to fill the gap. The remaining 1 package only has minified code, so I couldn't tell for sure. So yes, the 1 package out of the top 5,000 might actually need top-level weight. So from the sample, we can probably safely assume that top-level weight is mostly intended for entry points and scripts. They are actually pretty rare in packages that need to be loaded by a different code base. So we can at least say, well, require ESM works for 99% of the high-impact packages. For the other 1%, they can still be loaded with dynamic import. But we have something that's good enough. We also confirmed that unflagging it do not break the usual ways to load these high-impact packages. And then we also did a bunch of research into how to help the existing code transition into shipping ESM. I won't be able to cover them all, but I'll pick a few that are more representative for implementers. So first, for ESM, the ESM transpile into CommonJS turned out to have some special traits that we need to mimic. So a key difference between CommonJS and ESM is how they handle default exports. In CommonJS, the name exports are assigned to module.exports, which is returned by the require call. So on the left, the require call could just return the logger class, because that's being assigned as module.exports itself. In ESM, people tend to use the export default syntax to replace module.exports assignments, but that will actually be put on a separate default property of the namespace parallel to the name exports. Like here on the right, you can see that the logger is the property of the imported namespace object. It's not actually directly returned as by the dynamic import call. So, and this shape is mandated in the spec. So to handle this difference, when transpiling ESM to CommonJS, bundlers and transpilers have developed this convention. They make the exports object shaped like a ESM namespace with the default and name exports being separate properties, and a special marker underscore ES module. Then on the consumer side, if the consuming code is also full ESM, the transpile code would contain some adapter to unwrap the default exports in the presence of this marker. So here, the transpile consumer code can unwrap the logger correctly. Now, suppose a package was previously shipped as transpiled or full ESM, and now it wants to ship itself as a native ESM and get rid of the build step. But the consumer code may be maintained by someone else, and that could still be full ESM. And if we return the module namespace as is, as you can see on the right here, because there isn't a ES module marker for the transpile code to recognize the shape of the namespace, it won't be able to unwrap the logger from the default property correctly. So the solution was basically follow what the bundlers do. Let Node add a ES module marker when there are default exports, so that the consumer code and the module code can still be migrated independently. But the problem is ESM namespace objects are not mutable. Even as a host, we cannot just add a new ES module property to it. So we had a long thread to brainstorm with folks from different projects about how to do this. There were multiple ideas to hack around this. Either we put it on the prototype chain, or we copy the property descriptors over to a new project object, or we return a proxy from require, or we can use a new module that re-exports from the original module and put a ES module marker on top. So I implemented them all and did a bit of performance analysis. So here are the benchmark numbers from loading a bunch of real-world modules as benchmark. As you can see, the impact on module loading itself is very minimal. But I also benchmarked the performance of accessing the exports from the required ESM, which matters for full ESM consumers. The previous examples were a bit simplified. In reality, they do not cache what they get from the returned object. They always look up the exports dynamically from the returned object to maintain the live binding. So as you can see, the performance numbers vary greatly here. The fastest one was suggested by Bun, which puts the original module namespace on the prototype chain of the return object. But this will make the original export names no longer enumerable. The second fastest one overall uses the source text module facade, which wasn't as fast on the first try, but it has enumerable keys and look the most similar to the original results. So behavior-wise, it's the most desirable one. So then we did a bunch of optimizations on this approach. Most importantly, we only use the facade when the original module contains a default export. And we also cached the facade compilation, and we brought the numbers to a satisfactory level. So that was what we went with eventually. And the default export difference can also be a problem for packages that are previously written in CommonJS and now want to migrate to ESM. So previously, this is how you would write a CommonJS module if you want both ESN and CommonJS users get both the default exports and ning exports properly. As long as you assign to module.exports explicitly, the static analysis can detect ning exports from ESN for ESN consumers, like the .log here. Now, if you upgrade this to ESM, because ESN doesn't put the ning exports on the default exports object, you would need to assign yourself for CommonJS to get the ning exports. That is not too hard, but the default exports are now different for CommonJS users because it's now placed as a separate property named default. So like here, the CommonJS users have to unwrap the logger from the required result themselves. That means the migration will be a breaking change for CommonJS consumers. This is not a problem if the module doesn't have default exports, but significant amount of them do. And in that case, Node needs a hint from package authors to customize what required ESM should return. And we can unwrap default based on the __ES module marker because existing faux ESN code would need that to be left to them. So we had to add another marker. And we chose module.exports with the string exports because export something as module.exports seems easier to read and remember. So with this addition, a CommonJS package can migrate to ESM while maintaining backwards compatibility to both ESM and CommonJS users, even when it has default exports. So we talked about faux ESM and CommonJS. Now, what about dual packages? Here we have a common pattern of dual packages to prevent the dual package hazard mentioned before. They may use the no exports condition in package.json so that when the package is loaded in Node, they always supply the CommonJS version to both require and import to avoid having two copies of the same package in the same graph. In other environments, like when being bundled for the browser, they supply the ESM version. But now that we have require ESM, on newer versions of Node, they can always supply ESM to require as well. That seems easy, and they can then just drop the transpile CommonJS from the distribution, right? But we found out that not every package wants to do this so quickly. Some of them still have to support older versions of Node for some time, even though they would like to go ESM first when being loaded on newer versions of Node. So we need a new export condition for Node that supports require ESN to pick up ESN even when it comes from require. Now, bundlers actually already have a conventional condition named module that can be used to supply ESM to require, which allows them to transpile and produce cleaner code. We tried picking this up, and to be cautious, we implemented first and then tested it out on high-impact packages. Unfortunately, we found out that existing users of this condition, including some very high-impact packages like the SDK of AWS and Sentry, are using non-Node resolution rules in their ESM code. So if Node pick up these modules that are using resolution rules only supported by bundlers, we will break them. So as much as we wanted to implement the existing condition and save people from the mental burden of like one more condition to avoid the breakage, we ended up having to add a new separate condition instead. This is called module sync. Since require, we expect them to be synchronous. So with this condition, early adopters can supply ESN to both require and import on newer versions of Node to test things out and fall back to CommonJS on older versions of Node. And hopefully, when they no longer need to support older versions of Node, they can just drop all that and do this. And hopefully more packages can just be this simple in the future. So we did a lot of research. We added a bunch of features to improve the adoption of ESM. Most of these was done on the main branch during the period when 22 and 23 were the current releases. Require ESM was unflagged in 23. Then we started the backporting. Now, backporting to 22 was relatively easy because the release branch was not too old, but backporting to 20 was really challenging. So I first tried finding all the commits that are related to the module loader and also missing from 20. There were like 119 in total. And as I walked through them, I realized that some of them had breaking changes that would be difficult to modify into a shape to be backported. So I changed the strategy, and I took a bit of time to identify 32 commits out of them that were just essential to require ESM. And because many related changes were left out, almost all of them needed to be rewritten a bit for the 20 branch. And I had to verify that the commits were adapted correctly after the changes. So I also wrote a script to diff the diffs. And this is what the diff of diffs looked like. I tried to keep track of all the changes in the backported commits and summarize them into the pull request description for posterity in case something went wrong. And I think it didn't. And finally, this is where we are now. Require ESM is currently a release candidate. That is the last state of the experimental stages in Node. It's available without flags in 24, 22, and 20. We plan to stabilize it soon after it's more battle tested. And at that point, that will just be a documentation change. So last month, Node 18 reached end of life. So now all active LTS releases of Node support require ESM. And we are already seeing popular packages that either started shipping ESM only or are planning to do so. We still have a bit more work to do, like consolidating the synchronous and asynchronous linking path, because we kept them separate for the ease of backporting. Now we need to kind of consolidate them back together. We also need to provide in-thread synchronous loader hooks for the ecosystem to stop depending on the internals of the ESM loader themselves. And then we also need to improve the performance of ESM because there is still a gap between ESM and CommonJS loading. So lots of work, but it looks promising, especially now that we have more feedback from packages adopting ESM for real. So yeah, that's the end of my talk. Thank you for listening.
Hi, do we have any questions in the audience?
Here, Mike.
This was a big pain point for me, so thanks for doing this work.
Thanks.
Well, perhaps I should.
Yeah, this is such an amazing story, and it's really cool to see it, and thank you so much for all the work you did, especially the backporting. Sounds absolutely horrible, but I really appreciate it. In the early part of your slides, you had showed like graphs of adoption between, I think, like ESM and FO and CJS and these things, and it looked, I was just really surprised, it looked to me like ESM adoption was going down through 2024 and 2025.
So I think one of the key reasons was that this tool, it detects the dual packages based on certain patterns, and that has a lot of, I guess, false negative. So it was actually detecting certain dual packages as ESM. So that was why, for example, I think somewhere there in the pie charts, I kind of corrected them a bit because some of them, like, for example, I mentioned that 500 of them are ESN. Actually, the tool produces 600. 100 of them are actually dual. So that's why the stats changed a bit.
Hello. I just wanted to add on to the part earlier in the presentation regarding why require ESM was not originally looked into more. And it was because on the the Node modules working group, we had assumed that top-level await would be far more prevalent than it ended up being. So I think it's a good lesson to always maybe back up your assumptions with data, perhaps. But yeah, I thought that might be interesting.
Well, I had a question. as well. I'm not sure if you mentioned it, but you started out with 119, almost 120 commits for the module code. You had to whittle it down to almost, 33, right? Because of the backporting and everything. After the end of all of this and require ESM merging, have you found any new wisdom regarding designing such features that require long backports?
I would say I would say like my original instinct about line sided will be easier to backport than line change was correct. It did save me a lot of time. And also a lot of conflicts I had to deal with were kind of like mass stylistic refactoring, which weren't that often, but sometimes they show up. So those are easier to deal with, but when they come up like frequently enough, it can easily get into a situation where like you need to change every commit, and sometimes they're not as straightforward, so you can mess up a bit. So I guess like when you have something that you really need to backport to older branches coming, maybe try to back down a little bit on the mass stylistic refactoring, especially not the ones that cannot be automated.
So my new PR regarding ESLint on all the code base is not going to be accepted.
I think in Node generally that would not be, like you need to do them incrementally, or like per file basis, instead of everything has to be done in a single commit.
So something that was good to hear was that you looked into existing patterns and tried to make this work with those as best as you could. And I'm curious if you looked into like non-Node use cases where like package authors, it's good that they can support Node still, but I think other runtimes also do similar sort of interop between CJS and ESM. I'm interested if you looked into how close Node's implementation is to some of those, or is it still a case where package authors might need to think a bit more with their code if they're trying to target both?
I'm not sure if I got the question correctly. Was the question like whether we were looking into helping other runtimes to implement the interop?
More so about the Node's implementation compared to, like, I think Bun also has something similar. And is it where an assumption for how this would work in Node would also apply to Bun, or is this something where the package ecosystem still needs to think a bit?
I see. The principle was follow what the bundlers do, because everyone follows what the bundlers already do. And because, as you can see, a lot of people were already running full ESN, so the behavior implemented, the full ESN behavior implemented by the bundler was like already the de facto standard in the ecosystem. So we just follow what they do.
All right. Thank you all for all the questions, and thank you for the presentation, Joyee.
Thank you.
Right. I would start introducing the next set of speakers while they set up. So the next talk is an interesting one. It's also a longer one, so brace yourselves. Amongst the speakers are Jonas, our newest, I think, or one of the newest TC39 delegates, who is a master's student at the University of Bergen studying computer science, programming languages, algorithms, and they're going to prepare their new thesis about parsing computer algorithms, which is fun. They found their appreciation for TC39 and for standards while working on the Upsert proposal, which is funnily named, I guess. But, you know, we do stuff like that. Then there's Mikhail, who is a professor at the University of Bergen, and also more sort of storied TC39 contributor. They're the solo, I think, right, chairperson of TG5, which is, oh, sorry. So they're the co-chairperson of TG5, and have been doing some great work regarding research in TC39. So basically bridging the gap between academia and our committee and its process, and interacting with students about our standards processes. And finally, we have Shane, who you might already know as an internationalization engineer at Google, and as one of the maintainers of HiCU4X, who, fun fact, and perhaps the most interesting one, is that he's a board game designer and organizes board game nights. So, if you're up for that, then you know who to hit up. And has been collaborating with Mikhail and others at the University of Bergen to teach students how to, or to work with students more accurately about how to work on TC39 proposals like Upsert, or how to put that knowledge into implementations. So here to talk about that, about engine implementations and TC39 proposals, please welcome with a huge round of applause our speakers.
Okay, good afternoon, everyone. So this project, even though there are only 3 of us now at the stage, has been done by 15 persons, 11 students and 4 mentors and 1 academic supervisor. Speaking of which, my name is Mikhail. I'm an associate professor of programming languages at the University of Bergen in Norway. I'm also a co-convener of the ECMA International Technical Committee 39th Task Group 5, Experiments in Programming Language Standardization. And I'm also a member of the ECMA International's Executive Committee. And in this project, I was an academic supervisor. So the question that we asked ourselves and the message that we want to deliver today is this one: how can we enable more contributions from newcomers to web engines? And me coming from university, I had this idea that, we have a lot of people who are eager to learn, and those people are called students. And at the same time, very few of them, probably none of them, actually have some prior experience in contributing to open source projects. Not even to mention large open source projects like web engines. So the question was, can we really pull this through? Can we really have students to contribute to larger engines? So let me talk about the setting of this project. So besides ordinary classes, we have this specialized classes which are tailored for students who are taking them. It's usually 5 to 7 students. And the students take those classes not just to get the grade points, but to really get the skills. And as you can guess from the fact that we are presenting here today, this was a successful story. So what's in it for us at the university? So first of all, we care about students making some real world impact. We want them to learn new skills. We want them to have new technical knowledge. We want them to be involved in open source and also in the standardization work. University of Bergen is an active member in programming language standardizations. We also have some members of our research group who contributed to Fortran, to C++, and now also to JavaScript. So for us, it's natural that we want to participate in this. So we want to bridge academia and industry, just another successful story that, okay, this is actually possible. We can collaborate. And what's in it for the browser vendors or the web engines? So using students can help accelerate prototyping or implementation of simple features, but actually, as it turned out, not only the simple ones, but also more sophisticated ones. And we naturally, at the universities, care about education, so we could, based on our own learning experience, prepare tutorials and educational materials for others. So how did we structure our project? So we looked into 2 proposals by TC39, Upsert and Temporal. And we ran 3 case studies. The first case study was to implement the Upsert proposal in SpiderMonkey with a support from a mentor from Mozilla. The second case study, we thought, okay, can we, based on the experience in the implementation in SpiderMonkey with a mentor support, implement this in V8 without a mentor support? And then the third case study was, can we explore something a little bit different? We wanted to indirectly contribute to V8 by contributing to a smaller browser engine, BOA, with mentors support. And our talk today is the presentation of these 3 case studies. And I am giving the floor to Jonas.
Hello, can you hear me? Great. I will be talking a bit about implementing the Upsert proposal, first in SpiderMonkey and then in V8. Quick about me again, I'm a master's student at the University of Bergen, currently specializing in algorithms and programming theory, and I'm probably the newest delegate of TC39. And also for the first case study, I had some other students with me implementing this and also writing a tutorial on the implementations. So quickly, what is Upsert, or the newer name, the get or insert? Very simply, given a key and a value, check if the map contains the key. If it does, return that associated value. If not, insert new key pair, and then return a new value. Very quickly. And this is a specification text for it. As probably many of you know, the specification text mainly says what the proposal should do, like define the behavior, and not necessarily tell you how to do it, but in a very abstract way say what it should do. So this is like what we're trying to follow in the start, and then we build on top of this later. So we started out with implementing it in SpiderMonkey, and SpiderMonkey actually gives you a version of JavaScript which I call self-hosted, and it's a very easy way to start with an implementation, and actually gives you a quite performant implementation also. It's very similar to ordinary JavaScript, plus minus some features. And it's very easy to learn on the go by just looking at other implementations and taking like certain ideas from them and adapting them to our solution. So now that we know like a little bit about the background, let's go take a quick walk through the good, the bad, and maybe not so much the ugly, because it wasn't that much of it. So the first thing we did when we actually wanted to implement it, we actually had to start by navigating the code base, or figuring out how do we find what we want. We quickly figured out we have helpful tools such as SearchFox for SpiderMonkey, which makes the finding of prior implementations very easy. And then when we figure out which folders and files we actually want to work in here, we can simply copy another's function declaration and then just rename it and tweak it to our needs. And these first steps you see here is just some boilerplate code that is very easy to just tweak to our solution, so we didn't really need that much help here. But on to the next step. Now that we actually have a function, it doesn't do anything, but we want to tell the engine about it, which means that we actually have to hook it in. And this is where it starts to get a bit more complicated. The hooking in itself isn't that bad, actually, but knowing where to, which files to look into and what sort of thing you should write is not very intuitive, as a new beginner. So here we actually needed some of our mentor support to figure it out and just point us in the right direction. And then we quickly figure out what the different arguments that we use here are. The next thing we went on to is just, again, looking at other implementations. We based much of our implementations on a map.groupby functionality, as it's very similar in how it works and what it should do. And by copying it and just tweaking a bit, we actually got a specification accurate implementation. But as most people know, we don't necessarily want a fully spec accurate implementation. We want a performance one. So as long as we match the observable behavior, we are allowed to tweak the implementation to make it more performant. And the main place for this is, of course, this for loop that iterates over all entries in the map. And we, of course, don't want it that slow. So then we started looking into, can we use some of the already implemented functionality for the map class, such as this map.has. Here it's std_map_has, which is just a self-hosted name for this function. And it is pretty straightforward to use this functionality, and you can call C++ code as it has been defined in, except that it was not exposed to the self-hosted code. It is easy to make it exposed. You just move the variable declaration in an H file from private to public. But so even though we figured this out ourselves, we still expose more functionality to self-hosted code, which we weren't sure was something we could do and go ahead. So we just had to have an okay from a mentor, yeah, this is something this is fine to do, and it's secure and it's safe. We also implemented another version of this proposal, the map getter insert computed, which instead of a value takes a callback function. That is, if the key doesn't exist, it evaluates the callback function and then inserts a key pair based on this evaluated function. And for performance reasons, we tried to rewrite both of these in C++. But actually, during our review, when we actually wanted to get it into SpiderMonkey, we got a comment that asked about performance on the getter insert computed version, as calling JS to JS code in C++ is actually often slower than just calling from the self-hosted, which means that we would then have to do some performance testing, and as it turned out, leaving getter insert computed as a self-hosted version was actually faster than rewriting in C++. So we decided to keep getter insert as C++ and getter insert computed as self-hosted. The actual rewrite to C++ was surprisingly easy, actually. It's a bit more boilerplate code that's also outside of this function, but most of the functionality is here, and it's sort of you just, again, look at our implementations and then just adapt them. And it's actually pretty straightforward. Most of the work is hidden in some functions called get or add, which was already defined. But during a refactoring of the map class done by Mozilla, in between our implementations and our actually wanting to push it into Firefox, it got removed, so we had to then re-implement it and tweak it a bit, and also the rest of our C++ code, of course. So it was some more work, but the refactoring was quite easy. Another thing we didn't know until the actual code review was that we had to reserve these function names in the common property file, which is just another way for the parser to make more efficient use of these names, as they're something it should look for. And after doing all this, we actually have a working implementation that you can find in Firefox nightly. Of course, we had to do some extra nightly stuff, adding some nightly guards, which we also needed some support from our mentor to just have some examples of what we should do, but also quite easy, actually. Now, let's take a look over on V8, which we did, of course, without a mentor. And V8, in the same way as SpiderMonkey does, gives you a language to try and make it easier to implement built-ins, specifically Torque, which is just a domain-specific language for V8. It's a high-level abstraction to, again, write built-ins functions. It has TypeScript-like syntax. A lot of built-ins are now defined in it, and we can model our solution by it. The V8 team actually gives us a starting guide and a user manual for Torque, which was very nice and helpful. And there also exists a VS Code extension to give you syntax highlighting and error messages instead of you having to try and compile it every time. So with all these extra things, was it easier to implement this functionality in V8 compared to SpiderMonkey? Not really, for some other reasons. A bit more about the torque. That becomes relevant later. Torque is actually transpiled to something V8 calls CSA, or Code Stub Assembler, which again is a sort of domain-specific language, which is also a mix with C++. Here you see from just the torque user guide, just how it all works. It takes the types and splits them up and generates some CSA code from this, and eventually compiles it further. So, as in SpiderMonkey, we wanted to base our implementations on other previous work done on the map class. So we started out just looking, and for now, all that's been implemented for the map classes are actually just this map.groupBy. But as opposed to SpiderMonkey, the implementation was not really that similar enough, and they had done some other work with it, which made it too difficult to actually use it as inspiration. So after looking around for a while, and then thinking about like the data types, we figured out that the set class uses the same data class behind. And we can just look at some functionality for this, like set union and set difference. And by looking at all this, we are actually able to do the first couple of steps of the specification quite easily. Another side note about torque again. It's trying to do do a lot of optimization. So it will complain if you have unused variables, at least if you don't prefix them with an underscore, which took me a while to figure out because the error messages I got when compiling was not very helpful, or they were hidden by a lot of other things. But this actually got fixed at some point. We didn't report it, but it got fixed at some point, and the transpiler now actually shows error messages that it will fail your compilation if you don't put an underscore before unused variables. Another thing is that since torque is a transpiled language, if the error shows up after it has been transpiled, it's often quite difficult to actually understand and parse the error messages that's been generated from this code. So let's look at actually the step 4.a, which is just a comparison, which was surprisingly another pain point. Now, torque does do some overloading of the comparison operator, but there is some comments there about since we're not sure about what types we're actually comparing, we cannot use this overloaded function operator. So which means that we have had to figure out which function call to actually do the comparison, which was not very easily found, but we figured it out. The next step is more about how do we call some already defined map functions, such as the map.set if you want to insert keys and values into the map. And there should be some way to call runtime functions such as this. I have not been able to figure it out. I have used probably weeks on it, did not get it to work. So instead we found another solution, which is just declaring the functionality of map.set and just copying over the body. And as it says, without mentor support, it is a bit hard to actually know what should we expose, what should we redeclare, and what should we change to make our solution work. And is there some other way of going around this? Now, I believe this is actually sort of the right solution, as you don't want to do runtime calls in V8, as it's not as performant as just inlining the code anyways. But we have no way to be sure without anyone actually looking over our work. So now that we have figured out how to write functions in CSA and how to expose them, optimizing the solution in the same way as we did in SpiderMonkey was pretty straightforward, since we sort of just did the same again. Lastly, we want to give a special thanks to Daniel Miner, which volunteered as a mentor for the first case studies. And I think I'll leave it over to Shane now to continue.
All right, you can all hear me? Great. I'm here to tell you about case study number 3, which is Temporal in BOA and V8. So a little bit about me. I'm the convener of TC39TG2, that's the Internationalization Task Group in ECMA. I'm chair of the Unicode IC4X Technical Committee. That's my GitHub. But the hat I'm wearing when I come to speak with you today is as a mentor from January to May of this year of this project with the University of Bergen. So first of all, just a little bit of an intro. Hopefully most of the people in this room are a little bit familiar with the Temporal proposal, but if you're not, it's the proposal that brings modern date and time types to ECMAScript, and these are the types that it brings into the language. This is a proposal that is consistently rated as one of the top proposals for having demand from developers. So as it turns out, with dates and times, as you might know if you've worked with dates and times before, dates and times are challenging. And they're just as challenging to implement in an engine as they are for you to use in your developer-side code. So I'm just going to give you 10 example reasons why implementing Temporal in an engine is challenging. One is that it is a giant specification. In fact, the temporal specification, the temporal proposal, when it's written in EC markup, is longer than the entire ECMA 402 specification for the Intel object. So it's quite a big proposal that needs to be implemented. The Intel proposal took many years to build up to where it is now, and Temporal is like, go do it all at once. The second reason is that as being a very large proposal, it's sort of a mini specification in itself, and there's lots of changes that get committed to it, both normative and editorial changes, which creates a bit of a moving target, so that if you're trying to do like a multi-year project, implement Temporal, and then the Temporal specification is 50% change from what it was 2 years ago, it's a bit of a challenge. The third is that there's, of course, many edge cases. What happens if you add a month to February 29th? Like, I don't really know, but there's written in the specification somewhere. Someone needs to figure out what that means. Many different types of edge cases. You have to integrate with a time zone database. Typically, engines ship a time zone database, and that's different between each engine, and the exact interface that you have there, trying to interoperate with the time zone database from the operating system if you have one. We have to figure out how to do that with Temporal. We have to have calendrical calculations. We have to be able to figure out if you're in a Hebrew or a Gregorian or a Chinese calendar, exactly what should we be doing and what's the right thing to do in those cases. After we land the specification in an engine, it is a large code base for the engine to maintain, right? So the bar for landing this code into the engine is a bit high, because it's like, well, you're adding all this code, all these lines of code, like who's going to maintain this code going forward? That's a challenge. Many proposals, like the one you just saw, like one person can probably fit the whole proposal in their head. Like, that is not going to happen with Temporal. And like in general, like, you need a team to implement this. It's not possible for just one person to implement it. Don't want to say it's not impossible. I don't want to say that contributors like Anba are not like can't do it. But like, for regular people, like you're not going to have one person implementing all of Temporal. We need to be able to align with the rest of the specification, so there's a lot of testing that needs to happen. Everything needs to be reasonably efficient, and of course, all this needs to be interoperable across engines, right? You have V8, you have SpiderMonkey, you have JSC, you have all the other JavaScript engines that run on different types of embedded devices and everywhere. Like, we all need to agree somehow. So there's a couple different ways that we looked at for how we can implement Temporal in an engine. Two of these approaches. One of them is to just land it directly in an engine, right? This is what SpiderMonkey did, where you just land the code in your repository and you're done, right? The other way, which is the way that I'm going to talk about more in this presentation, is what if you can use a third-party library to implement it? So let me talk about using a third-party library. So what does this mean? It means that what if you can take the specification and you can write it in a library, in a standalone library, in a standalone package, just like a package that does one thing, which is implement Temporal, and then you can have engines use the library to just add their bindings so that you can use Temporal in your engine. There's some advantages for considering this type of route. For example, it has a lower upfront review cost and maintenance cost for the engine because the engine only has to maintain a thin wrapper layer that does JS bindings. It doesn't have to maintain the rest of the implementation of the specification code underneath it. A second one, which I think is really important, is that it brings a bigger ecosystem to maintain and improve the library over time because the number of people who can really learn to contribute to an engine directly, like SpiderMonkey or V8, right, have to go through the whole learning process that we just heard Jonas tell us about, right? But if you can implement this in a nice standalone library with a lot of tooling around it, like you can build up a much larger ecosystem. You might even have non-engines just who want to use Temporal, like maybe even use this library in non-web context, right? And then some success stories here. Intel is in every engine that I know about implements it using a library. Regular expressions commonly use libraries. JSON and other things also tend to use libraries. So this is not completely new. There are examples of this in the web platform. So I'm going to talk a little bit about this slide now. If you've contributed to Chrome before, you might be a little bit familiar with this diagram. This is the Chromium, what they call the rule of two. The rule of two means that when you write code and contribute code to V8, it can be two of these three things. It can be written in C++ in an unsafe language. It can process user input, and it can run with no sandbox in the browser process, right? And you don't want to do all three at the same time. And Temporal is a library that we want to be able to have, we want to be able to process untrustworthy inputs because it's a user-facing library, and it needs to be part of the core engine. So how do we do this? That's when Rust comes in. According to the Google security blog, this was published over a year ago now. This is a screenshot I took, so these are not my words. This is why they're choosing to bring Rust into Chromium. I don't have to read to you all the details here. The one that matters for us is that it helps us solve the problem of two by being able to implement code in a safe language. So let's go ahead then and talk a little bit about, I'm going to introduce to you some concepts which I'm then going to wrap together in the slide that comes after this one. So let's talk about BOA and let's talk about Temporal RS. So how many people here have used BOA or heard of BOA before? A few people. Actually, that's like almost half the room. That's great. It's a JavaScript lexer, parser, and interpreter written in Rust, which is quite cool. And Temporal RS is a standalone Rust project that BOA has been using to implement the Temporal specification. Temporal RS used to be part of BOA itself, and then we worked closely with the Temporal maintainers to pull it off into its own library called Temporal RS. So the state of Temporal in Rust gives opportunities for V8. One is that we have a library that is specifically aimed to be compliant with the Temporal specification. A lot of people are like, oh, can't you just wrap an existing library like Rust Chrono or something like that and implement it in the library? Well, not really, because it doesn't implement the specification. It doesn't have all these edge cases the way that Temporal says they should be, right? ECMAScript made certain decisions about how you handle all these edge cases, and those edge cases have to be handled in that interoperable way, right? So the advantage of this particular library is that it aims to actually implement all of the things that Temporal needs the way that Temporal wants them to be solved. And it's the only library that we're aware of that does this way. The lead developer of BOA is conveniently a Temporal proposal champion, Jason Williams. It's written in Rust, would solve the rule of two problem I just explained in the previous slide. And another sort of side benefit is that it gives us an on-ramp to use other libraries like IC4X. I'm the chair of the IC4X technical committee. It gives us an on-ramp to be able to use that in other places in the V8 engine. So this is basically what the architecture looks like when we take this library-based approach. We got Temporal RS that depends on various different components. It uses IC4X to do the calendrical calculations. It uses other libraries to do things like IXDTF string parsing for dates and times. And then we've got the Temporal RS, which is then used in both engines, BOA and V8. So, but again, what am I here to talk to you about? I'm here primarily to tell you about this case study in terms of my cooperation with the University of Bergen. So what I did was over the last several months, we did a project that I mentored a project to bring Temporal RS to spec compliance so that we can use it in V8. So I mentored 6 students that you can see here in the form of a weekly 1-hour meeting, and I also gave a little Rust mini course at the beginning of the semester so that we can get onboarded and hit the ground running in writing Rust code. The students contribute primarily to the Temporal RS library, as well as there's one student who contributed also to the test 262, and there's one student who contributed to the bindings into BOA. But this was primarily a Temporal RS project. I want to give special thanks to Kevin and Philip. I think at least Philip is in the room here for responding quickly to pull requests and helping us land those and helping us get unblocked. Okay, so this is what the code kind of ends up looking like. So Henrik is one of the students that I mentored. This was a commit that he landed just a couple weeks ago. And the left side, we've got the Temporal RS code. So this is just a regular like Rust library. It has a function. The function has like it's statically typed, and it has an API that's very similar to the Temporal specification, but in a very more Rusty way, right? On the left side, and on the right side we've got like BOA code, right? So this type called plain year month and plain month day. Those should be the same. That's a typo on the slide. Those should be the same type. But we have this type on the left side. It's like the Rust type. On the right side, it's the like JavaScript wrapper type. And then the code on the right side calls the function that is then living on the left side. This is basically the whole. What you see on the right side is basically the entire BOA code. So basically, it takes the object. It checks that it's like a valid JavaScript object. It validates some fields, which I elided that part, but it's basically like, is this field in range, right? And then it calls over here in the Rust crate, it calls that one function, and then it basically converts it back into a JavaScript wrapped object that it can return. So the BOA code is very small, and then all the complicated spec logic lives on the left side inside the Rust library. All right, so here's my favorite slide in the presentation. The goal was to take this Rust library, which when we started had not such a great spec coverage, and bring it up to higher spec coverage so that we can then leverage it. In Q4 2024, this was the test 262 coverage of the BOA engine. It's about 37%. There's a big gap. By Q1 2025, right before we started the Bergen project, it got to 67%. That's after Kevin landed some time zone calculations into the engine. And then I think we can take credit for most of this last jump here from 67 to 92%. That was the work that we did with the students at the UIB in order to get this library up to 92% conformance. And just as of like a few weeks ago, we've also now done the second step, which is, okay, what if we take the library and wrap it into V8? And this is code that if you build V8 and run the REPL, you could get code like this running. And this is running using Temporal RS. This is running using Rust code in V8, which like a year ago was like not something anyone was like, is that ever going to happen? Well, this is running like if you clone V8 and build it right now, you can do this. So this is V8 using a Rust library to implement Temporal. My colleague Manish, who's not with us today, has been driving this side of the project. It's possible that we'll work with additional students and other things to sort of help us build up the V8 side of this. Cool. I have just a couple slides left for you. The first is going to be lessons that we've learned from using this approach to implement a big proposal. So first, some successes. Overall, using a library, we were able to reduce the barrier to entry. So we were able to implement almost a dozen different functions. We were able to, we started with, I think, the duration total function, and then we implemented a lot of things like a lot of type conversions. When you just saw was like plain year month to plain date. So we implemented a lot of different functions that were stubs, and we filled them in with actual code. And in order to do this, like all we had to do was like use a very a fairly large a fairly large ecosystem that exists of Rust courses. So like if you want to be able to contribute to a web engine, all you need to do is like learn how to write Rust code, and if you can do that, you can contribute to an engine. You don't have to learn how an engine works, you just have to learn how to write Rust code, right? So this, I think, really did help us reduce the barrier to entry and help us really scale out and have these students be able to be more impactful. Second is that the library is also more amenable to long-term maintenance. For reasons I stated earlier, you know, we now that we have like all these students and a much bigger group of people who can review this code, right? We can also maintain this code moving forward, as opposed to just like a very small number of people who've like onboarded into how do you write V8 JavaScript bindings. And one question I get a lot for like, well, like why should I use Rust? Why can't I just use C++? We've been using C++ for years. One of the big things for me is that, you know, I'm a very busy person, as I'm sure many of the people in this room are. Like, I don't have time, like when someone sends me a pull request, to be like, does this C++ code have a null pointer exception somewhere? Like, am I going to have a dangling pointer? Like, I don't have the time to figure that out and think about that. With Rust, like, if they submit a Rust code that's fully safe, like, it's not going to have a dangling pointer, which makes it much easier for me to review the code and be able to scale out to a much bigger ecosystem of contributors. These are some lessons learned and areas we need for more discussion. Things that we should work on. Some maybe drawbacks of this approach. One thing we found was that when our students were implementing these functions, they didn't have a way to test them, because like, you know, you write the code in Rust and then you want to test it, like you can write a unit test, but really what you want to be doing is running the test262 suite, and now you're like one step away removed from that. The way that we resolved this issue was that we had all of the BOA functions implemented as stubs. So like we implemented the entire wrapper layer before we implemented the spec text. We had like, you know, like to-do comments inside the Temporal RS code, so they were stubs, so that we were able to go and then run the test262 test very easily and quickly. I think that's probably a good approach to be able to solve this kind of problem, but this was one pain point that we experienced. How do you run test262? A second one was, you know, it requires an extra, you know, for students getting onboarded into Rust, it does give a little bit of a more, it does require a little bit more onboarding, you know, relative to what you learn in your class. You might learn how to write C++ or Java in your class, but you don't necessarily learn how to use Rust. Hopefully this is changing. As more, you know, universities sort of, you know, teach Rust in higher level classes and things like this, but like this does, you know, it's a little bit of a barrier to entry. The third is that we found this especially when we were doing the V8 wrapper, is that handling of slots and option validations works differently. What I mean here is that the temporal specification is like read field, validate in range, read field, validate in range, read field, validate in range, and then go do the rest. But when we're running in Temporal RS, we already need to have everything read before we can actually run the spec, which means that like we then process options in a different ordering. So this is still a question that we're still working our way through. But that's one thing that I think this is more a question for spec authors. Like, please write your specs in a way that makes it amenable for, you know, putting into a library. And then, you know, this is a question that I sometimes get, like when we're talking about libraries. It's like, well, libraries are great, but if everyone uses a library, then do you really have multiple implementations? Because part of the point of being on the web platform is you want to be able to have, we want to be able to make sure that the specification is actually implementable multiple times. And if you have multiple engines all using the same library, do you really have multiple implementations? So like that's kind of an open question. You know, with Intel, like everyone basically uses one implementation. We're working on changing that though, but with IC4X. But this is just generally a question and a good just some food for thought. So I think at this point I get to turn it back to Mikhail to close us out.
Thank you. Yeah. So to conclude, for the Upsert tutorial, for the Upsert proposal, the students were able to implement it in both SpiderMonkey and V8 with and without a mentor. And coming again from an educational institution, we thought that it's sort of our duty to share this learned knowledge with the community. So the students have written themselves a tutorial, pretty detailed, one on how to start contributing to SpiderMonkey and V8, and how to essentially replicate all the steps that they have done in course of the case studies 1 and 2. And for the temporal implementation, we took a different approach, where instead of trying to teach the students on the details of the V8 engine, we took a different approach and leveraged standalone Rust code. Essentially, this greatly lowered the barrier of entry for the students, and we were able to benefit from modularity and reuse of implementations. We will also have a breakout session on Wednesday at 12, where we will discuss more detailed how to involve students and also researchers in web engines implementations. Thank you very much.
Thank you all. Hi. Thank you all. Because we're short on time, let's make the questions quick and fast, if we can.
Okay, since it's supposed to be fast, then I won't sing you Sangerhilsen. Otherwise, I would. But yeah, I guess you kind of already answered this. But as an author of yet another JavaScript engine in Rust, how do I contribute or collaborate with Universiteetti Bergen to work with your students?
Well, you are very welcome to do that. So, as a co-convener of TG5, the TG5 maintains a list of open issues. The student projects are not necessarily there, but we can still do that. So you're very welcome, and we will be very appreciating your collaboration. So I can just probably talk to you after the session.
Yeah, hello, is this good? Yeah, I want to first I wanted to say congratulations for the work. This is really great that you're doing here. And I have a question regarding like the initial part that I don't see that you describe it. It's like, how did you pick these tasks, and do you have any other tasks in mind, and did you have any learned lessons about what kind of tasks are interesting in these environments for the students?
Okay, so for the Upsert proposal, so this was in I think in June 2024, so last year, at the TC39 plenary, there was a discussion about the proposals that haven't been actively worked on, and Upsert wasn't worked on like for 5 years back at the time, and then initially we planned this as just a way for the students to get some experience in implementation of that old state of the proposal, but then it actually kind of turned out that it actually makes sense to revive the proposal, and yeah, so this was kind of not initially planned like that. Should you want to talk about the temporal, or?
Yeah, I can talk a little bit about temporal. So, we had this problem we wanted to solve, which is that we have the temporal RS library, which is at 67% compliance. How do we get it to 92%? Like, where do we get the resources to put behind this? Like, I want to find people on my team to be able to contribute to it, and like, we do have people on my team contributing to it. But like, how can we really accelerate this, right? And the Mikhail generously offered, like, do you want to mentor like next semester's pod of students who are doing this project? And I'm like, I think we can make this work. And I think that this is a good example that like we can make this kind of thing work, right? There's a lot of people who are learning how to code, and when those people they can contribute to like class projects, right? But like they can also contribute to something that has real impact too, right? And while also learning how to code in the process. So I think it's really a win-win. And like one reason that I thought Temporal RS was a good approach here was that like it is a self-contained project that has very clear that has very clear deliverables. So and it also has many different things that can be divvied out amongst different students. So I thought that it was very appropriate, and it ended up working out.
Yeah, this is all amazing. One kind of through line that I feel like I saw from the talks, the initial half was around optimizing this kind of simple function in the engines, and then the other half was like bringing in a library to do like a whole load of work. And I'm curious, do they run into conflicts? Like the idea of a library gives you this like very broad but unoptimized case, but doing those kind of very detailed optimizations within each of the engines, do you start to lose the value of a library? Or is there like, could you make a claim that like Temporal is not as well optimized as it could be because it's leveraging a library? And I'm just wondering if you could talk to that a bit.
Yeah, I can definitely speak to that. So first of all, the examples that I like to show, regular expressions, Intel, and JSON, are largely implemented in libraries. And like regular expressions in JavaScript are like, something where we can focus a lot on optimization. And in fact, by using a library, we can actually, we can use basically like all of the Rust tooling for like, how can you like optimize this code to run, very efficiently. So like you can, really focus on building a very, highly performant, a body of code that is in the form of a library, right? And then the question is really like, well, how can we make sure that the wrapper layer that sits between the engine and the library, like doesn't lose the performance that we've already gained when we've built this high performance, low memory usage library, right? And this is something that's I don't have the numbers quite yet for V8 because it's so new. Hopefully I'll have some numbers soon that we can share and look at. But like given the experience that we have had with regular expressions and Intel, like I think that this is definitely a solvable problem. And I don't think that writing the code natively in V8 is necessarily going to give you code that is faster than if you can write it in a library. I think this is largely an integration problem more than it is like an actual technical problem. Yeah, I think that's a good question. I need to think a little bit more about that. I guess my initial thought would be that like it makes a lot of sense for a library to be sort of a cohesive object, right? So like map upsert, is maybe more appropriate as like if you have a map object, maybe you implement the whole map object, right, in a library, and the map upsert can be added to that, right? So I think that's probably where we're like, at least initially, I think it would be appropriate to draw the line. Does that answer your question? Cool, yeah.
Right, thanks everyone. Of course, you can find all of our speakers at the breakout room as well as in the hallway around. Thank you for your presentation again. All right. Now it's time for lunch. It's downstairs, so you leave the auditorium, go towards the right, and go down the stairs. Thank you. See you after lunch.
Welcome back, everyone. We still have few folks coming in, so we will wait 2-3 more minutes before starting. All right, welcome back, everyone. While we still have like 2-3 minutes coverage, we could wait, or I can use this time to introduce our next speaker, who is Christian Ulbrich. Christian is a developer at heart and CEO of Zalari GmbH. He is a TC39 member and a host of Dresden.js. He's based in Germany. He loves web components and solving all your JavaScript and TypeScript problems. He loves to share knowledge and loves to laugh. That brings him to Coruña today. When he's not a developer or a CEO, he's either playing Ultimate Frisbee or running around in the city. Not from the problems, but for the health. All right, welcome, Christian. Over to you now.
Yeah, so thank you very much. I had a dream last week that I got roasted on this stage, and 10 minutes ago I thought, well, if I got roasted, that's going to be a big chunk for each of everyone. But now I'm glad that some people made it, some more people made it, so I'm afraid it will be a tinier chunk, but after the lunch, I guess that's satisfying. Okay, so let's get started. Yeah, but don't you mind? So I like to get like to be roasted. I have opinions, and surprisingly, I've also got arguments, so no holding back in the QA session. Some shameless self-plugs. Rocky already introduced me. I used to crack this joke that I have 10 years experience in Rust, but I've looked it up. Rust has been came into the world in 2009, so I guess this doesn't qualify me as a developer. Though actually, what I am having the most experience is enterprise JavaScript applications. I got a small development consulting company, but let's talk about versioned web components. So first of all, also getting to know who is asleep, who's not. Who has used web components? Raise your hands. Perfect. And what have you used them for? Microphones. Perfect. You get the 10 euros after the presentation. What else? Pardon? Yeah, a pattern library. Perfect. Yep. So I'm good to go. That saved me some money. So yeah, we have seen, that's also the experience that I have, that where have I seen them. So in Crosswork Framework UI libraries, and nowadays they are used in combination with microfronts, so they can be used as containers for microfront fragments. You can use them for a lot of other things, but I'm glad nobody said I've used it for this drop-down type-ahead select that is going to replace the crappy HTML select, because apparently no one has done this. So imagine. So and yeah, the idea is we want to use multiple versions of a custom element. So imagine we could something like that, and then could presumably in some magic way. So we define the first one, and then we have with the same tag name we have the second one. So that is what people want to do, and that is what I'm going to hopefully show how you can do this. But there is some prior art, so you can already, in a way, do that with something like called scoped element registries. And as the name is applied, it's about multiple custom element registries that are scoped to a particular element, and every web component that leaves beneath that scope can be its own, can have its own class. Yeah, so this is an existing exposal. Playing around with this very difficult scopes, getting scopes to understand, convey, is difficult. Closures, anyone? And I think one of the biggest drawbacks nowadays is that it's a non-declarative way, because the whole setup of the scoped custom element registry is done imperatively, so there's no representation in the DOM. So that is when you look at the DOM, you cannot easily rehydrate. And yeah, furthermore, development, I mean, the proposal is quite old, 5 years old, and at least in my experience, the adoption in the ecosystem is next to nothing. So imagine we could do this. So we have a tag name, we have our UI button, which is our custom element for that, and then we have a new version, UI button v2, and we register it with for the version 2. And imagine that it will look like that, so that you have you using the first one, that's the old one, and the new one is used with a version attribute. Well, introducing, I should have set up this audio system. Introducing versioned custom element registry, which is allowing you to do exactly like that. It's as easy as that. You define a custom element, you give it a version, and if when you want to choose to render which custom element, you do it with a version attribute. Well, so let's start some nice coding. I just need to find my... Ah yeah, there we are. So I think I'll make that one a little bit bigger. That one as well. Okay, so we don't have a polyfill in the beginning. We don't have that either. So, and we don't have that either. So that is what I said. So we have what we have here. I have a simple that's built with lit, but doesn't really matter. And I define it. So that's the button version 1. And so that will be that. So pretty easy. Okay. So I've already prepared version 2, and if I don't have any of the, so I can't do something like that. I can't do it. So you see the exception, because the tag name has already been taken. So of course I could do something like that. I could do something like that still today. Yeah, I could do that, but I mean then I don't have the same tag name, which has major implications in a lot of use cases. Okay, so let's use the polyfill. And add a version to it. Probably should change that one as well. Okay, so no, that doesn't be a string. So okay, so we see that one works. So I'll have the tag name, and I have the so I have the tag name, and I have the additional version. Okay, so and you see they both look the same. Why do I look like the same? Well, because that one obviously is the first one. It doesn't have a version associated. So if I give this a version, now we have two different ones. We have the I mean you can see this is so I could show you about instances. Yeah, and yeah, basically this is it. So but what are the things that sets this apart from so what are all other benefits that you get if you do it like that? So let's pretend that so if you're using custom elements, very often especially if you're using for your UI libraries, you can parameterize them by custom properties. So of course I can do that as well. Yeah. So probably something more recognizable. Yeah. So I have this in this button. I'm using a custom property, and the way I'm doing that is like that. So if I'm using now the second version, I have a little bit of a problem because now the second one, so this is the new version, gets the written. But luckily, as I've said, this plays along nicely. We can do something like that, and then it's fixed. So we can utilize the tools that we have. So because we're saying the original one never has a version attribute, or I mean this is subject change. Maybe might have an empty version attribute or something like that. And then we can leverage CSS to version things. And even if you're using the version stuff, we could do something. We could use those advanced attribute selectors, which match attributes which begin with a certain thing. So if you have certain semantics associated with the versions, you could also use it like that. And yeah, basically that's it. So I'll do a small recap. So scope element registries are heavy as a crown. So they have you cannot do that with scope element registry. What I also what I didn't show, but what is possible is that right now I can it has always the tag is always associated with the actual instance. So I can move it around and it always stays the same. And that also plays to the fact that everything is rehydratable. So whenever you look at the DOM, it is always giving you exactly the same what it actually is representing. So yeah, I showed the version element registry. I think it's easy to grasp. It's declarative. It plays nicely along with CSS, and it can be tested now. So what comes next? So I've prepared a full proposal. I'm fleshing out the existing proposal, and then I'll finally propose it. And I need to return my prototype into a proper polyfill. And I think to actually convince people, I should show it with a major UI library. I know what's the major web component UI library? Anyone? Does anyone wish? Lit is not a library. Lit is what you use to build something. Pardon? What would you say? Polaris. Well, never heard about that, but well, I'll give it a go. I thought about Shoelace, but Polaris. Sounds good. And yeah, so I'm looking for your feedback. So my first question would be, has anyone used scope element registries in production? Next one, would you use version custom element registry? At least one thumbs up. Yeah, so this is where will you get the proposal, and this is where you get the demo that I've shown to you. And I think I'm open to questions right now, but I've also got some bonus prepared, so yeah. So I don't know.
Thank you. Thank you for a talk. I have two questions.
Yep.
First, about versions. Are there supported only numeric versions or text versions as well, like beta something?
It's basically, there's nothing associated with version. It just has to be, it can be a string, can be anything. You just say, this is the tag name and this is the version for it. You can use numbers, you can use latest, you can use, I mean, the proposal is still in the works, but there's no, so the idea is that you can do whatever you want with it. So if you have semantic versioning for your UI library, you can utilize that and you can build upon that. But as you always are, you are the one to choose which version to use.
Mm-hmm.
But if you would semantic versioning, if you're using 2.1.2, you could use CSS selectors that target 2.1.
Yeah, if it's string,
so that would make sense. But there's nothing.
Not a problem at all. And the second question: is there any way to define a default version of the component?
Yeah.
Because I see the use case for this scenario, for this proposal you described.
Yeah.
But also I see the clear vision. I see it is necessary to have a kind of default version defined.
Yeah. So right now the idea is that the first version that gets defined is the default version. So if you this is something that is debatable, but that's the idea. Yeah. Or we could also, I mean, it could also be possible to add an API to custom element registry to set the default version for a particular tag. Although I try to keep the amount of API changes really low. Yeah. Yeah, but although you can, don't forget that you control the DOM, so you can always tie the DOM to any service that gets the version now to be used, and then you could change this. But there are multiple devices. So yeah. So come next.
Thank you for the talk, and thank you for the proposal. This is I just wanted to comment that this is excellent from the point of view where at work we have a collection of different components that come within the same package, which is versioned separately from the components within it, and the components are individually versioned. So I was looking at one point at the versioned registry or scoped registry spec and thinking, I don't know how I'm going to make this work with our system. So this is basically exactly what we needed. Thank you.
Yeah, thank you very much. Glad to hear.
Yeah, I also want to say thank you very much for presenting this. It's a really interesting idea. I think there are a couple of things that I would like to get into, if everyone will permit. This might get quite involved. The first piece of this is you mentioned scoped registries, and you mentioned their complexities. I don't want to get too much into that, but could you go back to the slide? I think there was some details in there that I just wanted to look at. So one of the things was the non-declarative nature of scoped custom element registries. So just as a piece of information, like there is a carve out in the current iteration of the scoped element registry API to allow for a shadow root to have effectively an open slot for a scoped registry, so that you can declaratively say that this will have a scoped registry assigned to it at some point. So there's some work in progress there on that. It's not necessarily fully fleshed out, but that is something that's happening. I am very curious about the difficulties, if you could kind of enumerate those so I could better understand what the problems are with scoped element registries, please.
So I think you can see the one thing. So if you load the scoped element polyfill, the scoped element registry polyfill, it's like, I don't know, 1,000 lines of code, and it's using all kind of tricks to actually make things work. And it has to kind of like patch around things. And the prototype that I have is, I know it boils down to 20 lines of code, something like that. And the one of the things is that in scoped element, they have to, the API surface, they have to change for the proposal is huge. So they have, and that's, I think that's one of the problems why it never came really into fruition, because you have to kind of, it is involving, so the implementation itself of scoped element registry in the browser is going to be complex.
I think you may want to look at the latest state of the art of this, because the proposal as described in this YCG explainer is out of date relative to the work that Anna has been doing in WebKit, that more precisely defines like a simpler API for scoped registries that would significantly narrow the amount of code for a polyfill. But I do understand and respect that there's like a practical difficulty today with the relative lines of code. But I wonder if that is something that will always remain in practice when scoped registries ship.
And apart from that, scoped registries, they don't play well. They don't have an answer to what happens if you move an element around the DOM. So if you move an element from one scope to another, what should happen? And I mean, so you cannot retain state if you do that. You can, but if you do that, then you have problems. Then I mean, and as I've said, another problem is that it is the rehydration is difficult. And
I think that the steps outlined for the new what has been dubbed revamped scoped custom element registries does have some very well specified steps for what happens for move operations. I would also like to draw your attention to the atomic move API, which has a new custom element callback called moved before.
Yeah, of course, I've seen that.
Or moved callback. Which allows you to retain state operations.
Yeah, you can retain state, but if you have one scope which is saying scope V1, and you have one scope V2, and you move an element from scope V2 to scope V1, what happens? You can retain state, but then it still retains
the definition will be locked. So if you move to a tree which has a different definition, your definition is retained because your scoped registry is retained for
but
that
then
element.
You retain state, but then you lose rehydration. So then you have something in a tree that when you even then if you rehydrate, even if the scoped registry is declarative, you will lose the state.
Could you explain to me what rehydration is?
Rehydration means that the DOM is the state. So it means if I look at the DOM, it's exactly like that. So if I re-render it just from the DOM, I get exactly the same outcome. And I won't get that if I move an element which is scope based. I mean, this is a conceptual problem of scoped element registry. I don't think you can. I mean, I haven't looked at the new specs, so I looked at the published proposal. But I think that's one of the problems. I don't want to say the scoped element registry has its use cases, but I think my proposal could do the same things as scoped element registry could do. In a user-end way.
I could certainly acknowledge that.
And I think it is easier on many levels. So it's easier on the implementation level, easier on the user level. But I think we can chat all the time. But maybe we might give somebody else.
Yeah, exactly.
So I'm really.
There was another thing, but maybe I'll just Q plus myself.
Alrighty, yeah, I also want to second what you said, so please have a look at the updated specification now, because I think it solves some of the points. It will probably not solve your rehydration use case as it is called here. Regarding proposing that idea, the question is which body would you like to propose that to? Because if it would be a web platform API, I would see some issues, because one of the core principles of the web is that it is unversioned, which is basically a break of that principle here. Not saying it's bad, maybe it works great for use case, but I expect that it rather makes sense as a library, especially given my personal experience with the so-called DLL hell and comctl .dll version 5 and 6 and so on, yeah, which may cause problems for, let's say, general web developers.
I'll have a look at the update proposal. I don't know whether it's public, so I haven't found it so far. Concerning version, so the idea was using something also prior art. So you might remember there's something called XML, and it has a version attribute. So this is something I think that is it is something. I think it's something that's easy to grasp. You've heard that there. I mean, and I think that this is something that should be taken into consideration, especially since, in my experience, the scope it has never been. It is hard to understand, and it is. I mean, there might be other reasons, but I think components. If components are always having versions. And in the way when we said we want to bring components to the browser, I think we have to we did so many things. So that's so great about web components. They are natively supported in the browser. They allow you to runtime composition. But I think that you also then, if you want to do proper software engineering, you do proper components, you need also to do versions. And you need that's what I personally think. And apart from that, you're right. So right now my solution is not using any apart from overriding custom registry define, is not using any arcane hacks. It is just in itself. It's just using web components. And I think I'm running a little of time. But what I've done so far, I can also do like using proper slot redirection. I can do proper attribute reflection, stuff like that. And I can also do with the proposal right now, I can do runtime composition. So you can define a version for you can use that's built inherently into the thing. So I can say take this component of version 0.2, and then I have loaded the old one, and then I won't see the new one until it has been actually loaded.
Right.
Yeah. So are there any other? Yep.
Yeah, I had like 2 quick comments. One of them is like, I think, I guess the rehydration problem you've mentioned, isn't that already like pretty much existing? Like you already can have an element on different scopes if you move it across documents, right? So I don't see how that's generally solvable. And I guess, yeah, the other one would be like, basically, what's the, like, Dylan mentioned it here, but to me, maybe I don't see the advantage, other than having a default version, what would be the advantage versus having, like, UI button -1 or whatnot?
Okay, so two questions. So the first thing, I think you're wrong. So I've already told you, saying it's a good question. But with my approach, rehydration is possible because there's always exact match. So there's always the idea that you have a component, you have a tag name and a version, and there's always a one-to-one mapping. So whenever you express that, there's always rehydration possible. Be it wherever it stands in DOM, wherever you move it, it is always rehydratable.
If you're in a different document that doesn't have your registry, it's not, right? If you move it across documents, right, which is what I meant, it's just like you have an iframe with about blank. That iframe doesn't have an element registry, like doesn't have anything defined. You move it around.
I'm talking, of course, but if it were in the platform, that I mean, that if you have an iframe that you have in your browser has always the same platform, so there's no possibility that you have a version registry in the one and the if it were a standard. But I'm talking the major use. One of the major use cases are micro frontends, where you have like different fragments loading, and where you have a component where and it is in the way we are using web components for a lot of UI stuff. But you can use web components also for logic and to encapsulate logic in that. And it is possible to move one component to another micro frontend that is living inside the same. I'm not talking about from component to iframe. I'm not talking about those use cases. What I mean with rehydration is that if you have a look at the DOM, that you always know what you get, and you won't get that with scoped element registries if you move across the scope boundaries.
Right, but it's the same if you move across iframe boundaries, right? Like
No.
It's
I mean,
totally
in the same document. If I can have in the same document,
like if
can
you scope it at the
different
same
scopes.
document, but like conceptually, the scope registries are already a thing. It's just like the scope is the document, right?
No, the
So you
scope.
have
The idea of scope elements that you can, whenever in the DOM, you can add. You can have multiple scopes at the same on the same page.
Right. My point is that that concept, it exists at a higher level. Well, like you already have scope registries, just like the scope is a single document. You cannot create subscopes. The scope registries basically make that more flexible.
I think we might. I think we have to sort this out later. So I don't get your point. Sorry.
Yeah, that's all right.
Yeah, thanks a lot, Christian, Emilio, for question as well. I think it's time you both connect in the hallway.
Yep.
Yeah, thank you, Christian. Thank you very much.
Already? Yes. Thank you. Want it to go up already? Sorry? I just start typing already there.
All right, while Adrián is preparing his computer, I can introduce him a bit. He's my colleague, Adrián Pérez. So we both work at Igalia. And Adrián is a system person who turned into a web engine developer, currently focusing on platform integration, hardware bring-up, and release engineering. Earlier I said he works at Igalia, but there's a small interesting story around it. He started at Igalia as system administrator and then moved over to embedded application development and from there to web engine. Not the journey you would imagine if you started from system administrator, but a very interesting one. And he says when he is not around computers or he's not coding, he loves cargo bikes and uses his cargo bikes in winter in Finland when it's snowing and when it's icy. It breaks my brain because I cannot imagine how it's possible, but he does that. So yeah, to Adrián now.
But we don't have video. Now we do. That is good. Okay. And there we are. Okay. I guess everybody can hear right? Yeah, sounds like it. Well, welcome everybody. We're in the Web Engines Hackfest. I think I have put the right venue there. And well, there was a really nice introduction by my colleagues, so I'm not going to stop in here much. But I think I still look pretty much like in the picture. Different hat, though. I like hats, too. I think everybody knows about Igalia. We do a lot of stuff on web engines, but also on other stuff, like compilers, Node.js, the streamer, Mesa, graphics. Everybody knows. I don't want to stop here a lot. But let's go to the meat. And this is what I'm going to talk about today. Last time there was a talk in a Web Engines Hackfest about WP Android was over 2 years ago. And along the years, we have had a couple of kind of birds of a feather sessions, mostly for the people interested in the project to discuss how it was going to evolve and so on. But we have not been presenting about it to the wider public, how it has been doing. And that's what I'm going to do today. I'm going to go quickly through an introduction about WP, and in particular, how WP relates to making WebKit work on Android. We'll comment a bit on the project history, because when I went to check, it has actually been a few years that it has been going on. And then I will get also into what's the motivations when I get there for having WP WebKit running on Android, and also what's the current status and what we think is the next things happening around the project. So beginning with WP, well, in particular WebKit, because it's not a WebKit port, is WP is the port, WP Android is the WP port made to work on Android, so it's a bit kind of long-winded explanation, but it's going to be clear. Everybody knows here, because we're in the Web Engines Hackfest, this is a web engine, picks all your content, makes it look pretty, makes the cats appear, and YouTube videos have sound, and you can watch mother talking and listen to them and all that kind of thing. One of the things of WebKit, which is crucial for the work that it enables with for this particular project, is that it's portable, in the sense that, not portable that it can run in different platforms, that's of course yes, but portable in the sense of what we call a WebKit port is an adaptation of WebKit for a particular platform, which means it runs in more things that one can imagine. Along the years we have known about WebKit running in many places, and the thing is that because it can be made to run in many things, sometimes there's devices that have web interfaces that are running WebKit that we don't know it, because the web interfaces are designed to blend with the rest of the interface, or the whole interface is a web interface, but it doesn't look like one, because it's customizable enough that you can make it look that way. So I'm sure there's still places where it runs that we don't know yet. And in particular, WP, the WP WebKit port focuses on embedded Linux systems, embedded both in the sense of small systems and embedded in the sense of the web engine is embedded in a bigger system, and one might not necessarily know that it's there, in the sense that blends with the rest of the platform. Like I was saying, is what enables it to be in many places without maybe noticing. And yeah, that's what I was saying. And the thing is, it's very extensible. We can make many things on top of it. It has a public API that is designed for embedding. Gecko, for example, had at some point a Schulrunner, which allowed to use the Mozilla engine in other applications. It was abandoned at some point. Chromium is not particularly designed to do that. It can be done in different ways. For example, removing the browser Chrome and using the content shell layer, etc. So there's like side projects which add such an API to be able to make the web engine part of different applications or part of bigger systems. But that is intrinsical to WebKit. It's every WebKit port has a public API that is ideally, in our case, is stable and is guaranteed to remain stable for as long as possible. And that means the API, the embedding API, has to provide anything that a browser may need, and also other applications that may need to use it. But if one can make a browser with a public API, one can imagine that pretty much one can write almost anything. And having written that it has minimal dependencies, and the minimal has a footnote. It does have a number of dependencies, but it's remarkably easier to make it work on a new system, because many things can be made optional at build time, and the dependencies we have currently are not bleeding edge, so they are packaged in most systems or available in embedded systems already. Not on all of them, and I will mention about this later because it's a bit of a pickle in Android. But it means that itself, WP WebKit is not very big. Like, we don't bundle everything we need, but the things you need to have to build it and run it is not that much. The most complicated part is GStreamer, and if you are like port into a new platform, you can even disable the whole multimedia stack to have something running at first, and then you avoid most of the dependencies, for example. And when we talk about WP and this customizable, means that on Android, because WP doesn't, we need to provide platform adaptation and also a custom widget for the Android native user interface system. And that is, this is provided by 3 different components, and I was saying dependencies, yes, Android doesn't have many of the dependencies we need to run WebKit, but the GStreamer team has this project called Cerbero, or Cerbero, which uses the Android native development kit to build all the libraries that GStreamer needs. So we figure out if we have GStreamer built for Android, thanks to this. If we have the 3 or 4 extra additional things we need for WebKit, then we have everything already. So we reuse this project, and using the official Android native development kit, we are able to build all the dependencies for WP WebKit and WebKit itself, the WP port. And also the WP backend Android, which is the part that provides platform integration. And then we have what we call the WP Android proper project, which is what has the glue code that provides the widget that is exposed as a Java API, which is the usual thing on Android, and can be used from any other language that runs in the Android runtime Java virtual machine, and has some tools like a WebDriver host and all the needed glue code to make everything work. So WP Android is, in reality, these 3 projects put together. And if one builds it, one ends up with a mini browser, which is a sample application, which looks like this. Is quite simple. Could have a few more features, but it's enough to browse around, see that things work, and yeah, it's an Android application. Doesn't look particularly special from that point of view, unless one knows, well, this is not running Chromium, which is the usual thing on Android. First aside about the history of the project, I want to recap that WebKit has a long history with Android, because when Google released Android in 2008, it was using WebKit as the system web view component since the beginning. Because at that point, I suppose most of the people remember here, given the venue, Chromium had not been split from WebKit yet, so Chromium was another WebKit port. So they, of course, choose to use WebKit for that. And it was 2013 that they announced in April that Blink/Chromium would be stripped out from the WebKit repository and made into an independent project, and has been like that ever since. So it was also around that time that they decided to switch the Android WebView component to use Chromium. Some unofficial community Android builds kept using the WebKit-based WebView for a while, but of course eventually they had to remove it because it was unmaintained. And the moment where they did that was 2014 onwards, when Google made it so the Chromium-based WebView would be separate from the rest of the system and could be updated independently, which allowed them to avoid building Chromium as part of the build process of their Android system images, being able to install it separately. And as for why do we want to have WebKit running on Android again, it's one of the things, or one of the main things, is that Android as a base system is interesting for a number of reasons. One, which is very obvious, which is not even there, but doesn't matter, is that the installed user base is huge, which means if anybody needs to find a device to do some development or tinkering with it, or use it if at some point there's some application that is mass-oriented, there's already a huge installed user base. Now there's a different discussion about why somebody would want to use WebKit for that. We can get into that as well, instead of Chromium. But the truth is that there is a huge user base, and the pool, the influence of Android as a system is big enough that hardware manufacturers are providing support for their systems, for their chips, for their GPUs, etc., for Android sometimes, and not so good support, or if at all, for regular GNU plus Linux or non-Android Linux, let's say. So that means we get base system that is more tested, often has more features, especially when talking about GPU drivers, even though the situation has improved a lot in the last years, and which can be considered to be stable also from the point of view that Android has been pretty good at keeping backwards compatibility. So that means, in theory, it's a desirable target because we have all these advantages that would save us, for example, from dealing with different kinds of incompatibilities in drivers, in different Linux distributions which may be arranged in different ways, because an Android system, a system based on Android, is going to have a base that is the same for all of them, because at the end of the day, Google enforces that to certify devices that then manufacturers want to sell. So in that regard, it's a solid base system that is attractive to target. And another reason why we may want to run a web engine that is not Chromium on Android is that in some systems, we know that it's being used without the upper layers of Android. So you can use Android, the lower layers, like the kernel, the userland, that is native code, and libraries, drivers, etc., without including the graphic system, for example, and anything that needs the Java virtual machine runtime. And that is something that we have seen. And in that case, Chromium doesn't run because there is not a build option for Chromium that you can tell it, okay, I want to run on Android, but I don't want to use the Android user interface. That's basically not possible at the moment. But that is something that is relatively easy to do with WPE, because if we go back a second, if it wants to go back, it was here. We have these three parts that that we have the platform integration in a separate component. So if you don't want to run the widget part, the WebView widget that WP Android provides, you can ignore the last part. You can just not build it, and it works. So that's an advantage that we have, for example, over Chromium, and it's something that WebKit being more flexible in this regard allows us to do. And then there's other reasons why this project was started. I was like, we already had WP WebKit, and it seemed like a nice idea, just the thought of why not bringing back WebKit to Android, where it was at some point. If we have WP as a base, which is a port of WebKit that doesn't mandate a particular user interface or a particular user interface toolkit, so we can do the adaptation based on WP WebKit without having to write a complete WebKit port, which would have been much more work. So from that point of view, it seemed like a good opportunity also to prove that WP can be adapted to many different kinds of systems and not only regular distribution-like Linux systems. And of course, now we are getting into the territory of social politics, I guess. And one may also decide that doesn't want to rely on Chromium or on Google, who develop Chromium for the most of part, and then go with a different option. For whatever reason, there can be many. One of them could be as easy as the reason I was mentioning earlier, that I don't want to use the Android user interface, because I want to have something that uses the Android drivers, but not the rest of the UI. One may want to not use Chromium to make sure, for example, that you ship in your application the web engine that is a fixed version with a feature set that is going to be always the same. So you are targeting that particular web engine with a particular set of features, and you don't have to rely or be at the mercy of an update in Chromium breaking your application, for example. because you are with WP Android, the way it works nowadays is that you ship the libraries that make part that form it as part of your Android application package. So it's bundled with your application. So from that point of view, you know exactly what you're targeting. So it can be cost savings, for example, when developing an application that has web content and that you don't need to target different versions of the Android WebView, for example, which was more of an issue in the past when Chromium was evolving quickly, for example, or during the transition from WebKit to Chromium-based WebView. Applications that use the system WebView widget often would have strange bugs or would plainly not work depending on which version of Android you have, because the package with the WebView implementation would be updated as part of the whole system. So it was quite fragmented. The platform was quite fragmented from the point of view of the versions of the WebView shipping at the same time in many devices. And also another motivation that we think it's interesting is making a small dent, a small contribution, even if it doesn't end up used for applications that have billions of installations, to have like the proof that one can target Android with a different web engine, and it can work, and that contributes to have a more diverse web engine ecosystem, which is good for the web overall. I think everybody can agree to that. And yeah, like I was saying, I was checking, and we actually started in 2017 with this. Initially, I'm going to do a next slide, and then I'll go back. One can see quite clearly how the evolution has been. This is accumulated a stack plot of commits in the Git repository. This is only for the main WP Android repository, but it's quite a good example of how it went. And the decreasing of each stack line is commits that were at some point, and then they were being replaced, their lines, by lines in other commits. But anyway, the total amount is the total amount of lines. So yeah, it started in 2017. It was kind of a small demo project, that's proof of concept. And yeah, it was 2017, a small demo, got a bit, stayed there. Nobody was paying it much attention until 2001, 2022. Then we picked it back, rewrote some parts of it, and started to use Android's GL Surface view. But then the interesting things started to happen in 2023, which is not that long ago. And that's about the time when the last talk was done about WP Android. And at that moment, we got an NLNet grant to work on WP Android. So then we started working on it again. And the results of getting back to it started in 2024 by the beginning. For easiness of maintenance, we dropped 32-bit support. But for example, things which were running a bit awkwardly were integrated better, like the glib main loop, because we use glib in the WP port, got integrated with the Android main loop, which is good, for example, for battery savings and so on. We got multi-process working in the sense that security regions are isolated, that the process swap on navigation. We managed to get multimedia decoding on hardware using GStreamer's Android components, which offload the media decoding to Stagefright, which itself may have hardware acceleration. And 2024 August, a lot of things again, many new features. Like it can be, it's quite clearly like 2002 there's a bump, 2024 bigger bump, and then 2025 is where we are now, up top. Yeah, we're at the point now. At some point there was one of the things that was done during 2024 was reducing the amount of patches that were applied on top of WebKit when building it for Android in particular. There were at some point 170-something patches, and that went down in chunks of some tens of patches, some tens of patches. By 2025, beginning of the year, we had about a dozen only, and at this point, we don't have any Android-specific patch which is applied on top of the WebKit tree. That means that with the needed dependencies. If you build it, for example, using our Cerbero fork that has the needed recipes, the WebKit package that builds for Android is exactly the same that is distributed as a Torvald release for any other system, which is quite nice and makes development much nicer. Which means one can also point the build recipes to the tip of the tree, and at this point one can build Android from the tip of the tree without any change whatsoever. Something that may happen sometimes is because we don't have CI for the Android port connected to the general WebKit CI, is that there's a commit in WebKit that breaks the build for Android that we fix quick, but it can happen sometimes that following main will not build, but in theory should. And well, that's something that started in 2024. We are also maintaining a Maven repository. So if some Android developer wants to try to embed the web view that uses WP WebKit in their application, they can add one line in their package configuration, and binaries get downloaded automatically by Android Studio, for example, or any other development environment, and you can just use it. You don't need to spend 4 or 5 hours, 2 days figuring out how to build the whole thing and have it running. We fixed things to have it working on Android 15, which is the most recent version. It's currently the stable release is using the previous to last 2.48 release, which is the latest stable series. So it's basically following quite close upstream WebKit development at this point, which is quite nice. And yeah, we're even using Skia. It's possible to use GPU acceleration for rendering on Android. It works. It's not necessarily much faster than using Skia with software rendering, but it works, which is nice. And now we're at the point where I say, well, and what do we have coming out of the open soon? Well, there's a number of paper cuts that need quality of life improvements. Most of them are that there's either some platform API missing, in the sense that, for example, at this point, WP Android is not respecting the power status reported by the system. So if you're on battery, well, it's not going to be trying to use less battery. But that's something that can be done in the future. It's not terribly complicated. It just needs a bit of time to do it. There's APIs missing where we have been trying to copy or mimic the public API of the Android system web view. It just that instead of web view is called WP view, and then the methods tend to be the same if it's being used from Java or any other language that runs on the Java virtual machine. But many of the APIs that the system web view has are still not implemented. That's not difficult to do either. It's just something that takes time, and it's how is it called? It's menial work, right? But it can be done, of course. So that's more things that we need to do. Continue the regular maintenance, etc. We have ideas to reduce the size of the binaries that are pretty big, because we're bundling the streamer, for example. Even when not all of them are used, we're shipping also many of the GStreamer elements that are also codecs provided by the Android system GStreamer elements. So we have, for example, duplicated codecs that we wouldn't need to ship. But that's also things that take time, but they're not like strictly needed to have things working and continue improving things. What we would like to work at this moment on, or what we have the idea, is start picking commits from the main branch that we know work for Android, and make the main branch of the WP Android project follow those. So have a branch for the stable releases, and then that main follows main. At this moment, the main from WP Android is following point releases, but it would be nicer for testing to follow the WebKit main as well. And there's one item there that maybe doesn't sound very exotic, but we have been working on a new API for WP, and to give an idea, we call it WP platform. The old API, I'm going to call it the classic API. With the classic API, we have, for example, the mini browser that we have in the WebKit tree is about 600 lines and plus 1,000 lines of the WP backend that makes WP present content on Wayland. But if we get a slightly more featureful browser, like the launcher included with the Cog library, that's 3,500 lines for the part that implement the Wayland support, plus almost 5,000 lines from the backend, plus the launcher itself. So it's pretty verbose. And anybody who wants to do a different adaptation of WP to a different platform, including Android, has to go through a lot of that code. And it's not always the same code, of course, but there are things which are common. And it seems a bit wasteful from that point of view. And to give a taste of the new API, I like to put this example, because this is a complete browser with the new API. This will not work on Android, of course, because not directly, because it's C using the glib Joyee API that we have for WP, but it works on desktop Linux, and it's 32 lines. That's how it should be, ideally, to write something that opens a window with a web page on it, not 600 lines, right? And this new API that we have been working on for WP platform comes from the fact that the classic API has a number of problems. One is that it's very verbose, like I was trying to exemplify with the line counts. It's plain C. It is not well documented or not documented at all in some cases, which means also there is no hints often in the documentation about life cycle of objects and who is responsible to deallocate or allocate what. It's confusing sometimes what it does. The names of parts of the API, especially when implementing a WP backend to adapt WP to a certain platform, there are terms that make sense, but they're not the usual terms that one would expect. So one doesn't, for example, implement view implementation, that is what shows the view in something. One implements a render target interface, which doesn't sound like anything. It's like, has a lot of these terms which are confusing. So it's not a good API from that point of view. It has served us for many years, but we would like to change it. And what we're doing with the new API is we're basing it on GObject, like the same as the rest of the WP WebKit public embedding API, which means the roles of each object are clearer, the life cycle and who allocates, who deallocates, what is reference counted, what is not, etc. That is part of the type system. It's still C, but at least it's C with objects. And there are good practices and annotations that we can add to include that information in the documentation. And also, it can be used for linting, etc. So it is better from that point of view. It has already better documentation, even when it's not completely documented. It has better documentation than the old one. And the names make more sense. In general, like the idea is that the design of the API will encourage the people who are either writing a browser or writing a platform implementation to try to nudge them in the right direction to avoid having mistakes. And while working on it, we decided that we had a number of years of experience working with the old API, and we had reached some limits in what we could do with it, some odd corners that we couldn't fix without changing the API. So we took the advantage of designing a new one to try to fix those. So a nice thing of the new API also is that it's designed in a way that it tries to facilitate that, for example, when moving graphics buffers from one process to another, WebKit is multi-process, by the way, even on Android. By the way, the system web view, I think it wasn't multi-process until a couple of years ago. Anyway, but yeah, or when doing composition or different paths inside the graphics pipeline of WebKit, there is more information that allow to to avoid copying graphics buffers, for example, or transforming them, or changing their pixel format and so on, which gives us improved performance, but also other niceties like less battery usage, for example. Also, we wanted to make it use a new mechanism that we have inside WebKit that's called display link, which basically talks at a lower level than, so often at a lower level than the system user interface toolkit, to ask the hardware directly what is the moment at which you are presenting and going to give time to prepare a new frame, like related to vertical synchronization, if you want to think about it like that. So we can more efficiently schedule when to paint, when to try to have the painting ready to be displayed, and so on, which is something we couldn't do with the old implementation, with the classic API. So that's also something that that is coming for free with the switch to WP platform. And from the point of view of Android, there's a couple of issues that we have. This is something that is being worked on at the moment. Until these weeks, we have not yet added support for the Android hardware buffers to move graphics among processors. That is now being worked on. And the API doesn't cover, well, for those who don't know, Android has this thing that you cannot fork and exec processes like in a regular Linux system if you are using full Android with the whole Java virtual machine, etc. But there are system services that you can request to have a background process, etc. And you have to go to those through Java. So if you are writing the platform adaptation in C++, we have to go through the Java native interface, call up to Java objects, get the results back, and then finally we get a process launched. And that means we have extension points with the old API to launch processes, which are only used by the WP Android port, and I think the PlayStation port. WebKit has a PlayStation port. But we don't have those in WP platform yet. So yeah, we still have a few things missing. And while the WP backend API is still in flux and still moving, still evolving a little bit, it has reached in the last months the point where it's quite feature complete. And what we have been using in the last months has not changed much. So we are quite close to, I believe, quite close to feel confident to consider it 1.0 API, 1.0 from the point of view of now it's stable, and to start guaranteeing backwards compatibility. Until we reach that point, we may still change things in incompatible ways, but it has not changed much in the last 4 or 5 months. So we're getting there also with that. And we may do things like consider it stable without adding the process launching customization possibility, which as an addition wouldn't break the API or the ABI later. But we'll see. But we're close to get WP Android working with the new API, and well, for improved performance and battery usage. And that's where we are at the moment. So I would be super happy now if anybody has questions or doubts or comments.
Yeah, so in some, like for some application developers that use like basically websites internally, but develop applications as like Android and iOS apps, and even Electron apps or something like that in the desktop. They sometimes want to use one single browser engine to avoid differences. So and in that sense, I was wondering, how close would Android WP be to iOS in various extents?
Okay, that is a great question. How close would it be WP Android on? How close would be WP Android to Safari, for example, on iOS, if one wants to target it? And the answer is quite close, except for some APIs that are device-specific that we may not have implemented yet. So for example, I think we don't have yet orientation events, for example. There's WebXR is in progress. It doesn't have, like we have some WebXR support, but it needs rewriting. It's not very multi-process friendly in the way WebKit is designed, so we have to move to a model which is closer to Apple's. But it's the differences that there are is not because WebKit is not capable, it's because we either have not exposed those yet, or we are missing some kind of platform integration that would enable them. I don't have a list with me, but ideally, if we had all those implemented, they would be close enough that I would say 90%, 95% similarity, most likely.
Hi. Here, I'm curious, have you compared in terms of things like binary size, performance, etc., to GeckoView or whatnot? Because my understanding is that it's a relatively similar thing, where like GeckoView is the package that provides the WebView-like API. It's more oriented to Java, as I understand, versus what you're doing. But yeah, I was just curious if you had run any comparisons in that regard.
Yeah, so the question is if we have done performance comparisons with GeckoView, for example, or Chromium, I guess. No, we have not. We're at the point where we are focusing on having features implemented still, moving to the new WP platform API and so on. We know that there has been an increase in performance since the switch to Skia, which arrived a bit later to WebKit on Android because it has some platform integration to solve. And like the mini browser now built in release mode, like it's fluid enough to regular browsing on a mid-range Android phone, but we have not done like running motion mark or any other benchmarks until now.
Cool. Thanks.
Thank you, Adrián. Thank you very much. Very nice talk. Unfortunately, we don't want to hijack more break time. So it's break time, folks, and we will have our next talk in 18 minutes. So I'll see you all, hopefully in 16 minutes. Okay, hi everyone, welcome back. And we don't want to waste lots of time because it's already 5. So our next speaker is Mike Pennisi. Mike is a worker owner at Boku, where he has been contributing to web standards for over a decade. I asked him what is something he would like to tell to the audience that maybe people would be interested in knowing about him. And he says he curates a private collection of deformed breakfast cereals. I need to ask more questions, but probably afterwards. Okay, Mike, to you now.
Thanks. Folks can hear me? We're good? We're good. Great. So thanks for the introduction. I am Mike, and I do have that collection. I can share photos with anyone that's interested, of course, but that'll be a different presentation, I guess. And yeah, I do work at Boku. Boku is a worker-owned tech consultancy. We just became worker-owned as of this year, and yeah, I'm one of 5 worker owners. So good to meet you. I go as Juggle and Mike online, GitHub and all that, because that was a good idea when I was 13 years old. But my real name is Mike Pennisi, so there I am. Today, for this talk, I'm going to be talking about the automation efforts that are currently ongoing for assistive technologies like screen readers and basically anything folks use to help them access the web. I'm going to get specifically into the area of investigation that I have the most experience with, which is the AT driver standard. And also the AT community group that's out of the W3C that's doing work that's happening in parallel. And finally, I'll end up with some notes on future work areas that we've identified as things that we want to do in the near term and the long term, and that maybe folks here could pitch in on, but we'll see. So when it comes to making equitable experiences for folks with disabilities, it often feels like this work should have been done decades ago, and that's certainly how Alfredo here feels. You know, we think that these things should have been done a very long time ago. It's somewhat of a shame that it's just happening now, but it is happening now, and that's part of what I wanted to impress upon folks here today, is that there are a bunch of different efforts going on in parallel from different companies, different individuals. All different people are trying to make the situation better for not just the end users, but also the developers creating experiences for the end users. And so here on this slide, I just have a rundown of some of the projects that we've been interacting with or looking over as we're also participating in this space. The first is this a project called GuidePub, which is being maintained by an individual named Craig Morton. This lets you subscribe to a stream of speech being read by a screen reader. And this is like a really interesting project that's available today that you can install in GitHub, use in CI workflows, so that when you're writing tests, for instance, for your web application, you can actually learn at a programmatic level and a repeatable level in an automated way what's actually being vocalized or what would be vocalized by a screen reader to an end user using the screen reader. So this is really doing really good work empowering developers to understand how their work is being presented to screen reader users. Because without this, it's really just a manual process. It's like really tedious and that a lot of folks don't do. So right now, though, it is limited to one type of assistive technology, and that is, as I've said, screen readers. And there's nothing right now. It's not currently slated for any kind of standards track, which is probably important to note about. Especially, I guess, for this audience. Contrast that with the WebDriver protocol, which is it is a W3C standard, and that's over the past few years is being extended with new APIs for querying for essential primitives in the document that are related to how the screen reader or how web pages are presented to users using assistive tech, and this is things like computed role or computed name. Then that's great because it's not only is it standard, but it's actually shipping in major browsers today. So this is something that you can use right now if you want to. But it is somewhat limited. There's a lot more about the screen reader, the AT experience than just these couple these primitives. And for that, there's also the accessibility object model, which is itself being exposed through WebDriver, and this is currently undergoing design and early implementation, and that's as we speak. So I think what's really important about this is that it's being put into WebDriver, it's being put into WebDriver BiDi, which is a kind of new generation form of WebDriver. So there's a very clear standards track and a very clear implementation track and a very clear, I guess, adoption track, because so many developers are already using these technologies. So we're not to get these adopted. It's not pitching a whole new paradigm. And there's also the Acacia project, which is coming out of Igalia, that's targeting specifically the web platform tests and making the AOM accessible from web platform tests so that shared tests can be written in that project, and we can kind of get a better sense for the correctness of implementations at the level of the operating system mappings for accessibility. So this is a very rough and very fast overview of the space that we're also contributing another effort to, which we're calling AT Driver. And this is another W3C. It's an editor's draft right now. It's chartered under the Browser Testing and Tools Working Group, and it's a standard for basically automating assistive tech. Right now, we're limiting our focus to screen readers because we want to, basically because we have to start somewhere, but as the name implies, our scope definitely includes all types of assistive tech. And at a high level, we're basically trying to do a lot of kind of enabling the same kind of use cases that WebDriver enable for web browsers, but in our case for assistive technology. So that's still pretty vague. Well, that's pretty abstract. So screen recording demo, here we can see that we're actually using the AT Driver protocol to drive a screen reader and a web browser. So in this case, the screen reader is Apple's VoiceOver and the web browser is Safari. And we're running what's a test from the RAAT project, which I'll get to in a minute. But as the video loops over, you'll see that on the left, there's a terminal window that's showing us running a script that's actually capable of speaking. It's capable of speaking the protocol, and we're seeing a bunch of logging messages about the actual messages going back and forth between this screen reader, between the Node.js process, which is driving the test, and the implementation of the AT Driver server, which in this case is kind of a hybrid Objective-C and Node.js application. Yeah, I think we've probably watched that enough. There'll be another one later if you're really curious. But basically, what we were just looking at there, as I've said, is a protocol that we're developing under the Browser Testing and Tools Working Group. It's drawing heavy inspiration from the WebDriver BiDi protocol, and so some of the core concepts there that we're cribbing is that we're using JSON. You saw those messages going back and forth are JSON that we've serialized on a WebSocket connection. And so that's kind of central to how WebDriver BiDi is put together. We also borrowed their concept of the remote end and the local end abstractions and the idea of the commands and events as far as facilitating the actual communication between these two systems. And so we're doing this not just because we're lazy, although I certainly am, but also because we recognize there's a whole lot of implementation experience behind WebDriver BiDi. So we want to limit as much as we can of inventing our own, and we want to leverage their experience and the lessons they've learned from where they're coming from, because they're not only operating off of years of experience with WebDriver itself, but also with the experience of folks that made the CDP or the Chrome DevTools protocol, which is where BiDi draws a lot of its inspiration. So there's kind of a long lineage of thought behind where this came from, and we just didn't want to pretend as though we could do better. So that's why a lot of these ideas are coming from this kind of established protocol. But of course, this isn't the same space. It's not just that we're doing slightly different things, but the things we're trying to do are fundamentally different. so the user agents that we're trying to automate are not web browsers, so there's no concept of a browsing session, there's no DOM, there's no elements, and and also these are kind of inherently singleton pieces of software. So you can imagine, like in a web browser, it's very common for you to have multiple windows, multiple tabs, but it's very, very uncommon. Maybe it's actually very difficult to do, to run multiple screen readers. It's not a fun experience to even try. You can trust me on that. But so some of the things, some of the paradigms, and some of the decisions don't apply. And so we're open. That's why we're not completely one-to-one parity in terms of the design of these things. So with that said, I gave this overview of how these different efforts are all happening at once. And I think that when you just see it, when you hear about it for the first time, you can think that like this person is just talking about 3 different ways to do the same thing. So why are there so many ways? And why should we need even more? So I think it's useful to see laid out how these things are actually. There's distinctions here that are subtle but important. And so for that, I'm borrowing a diagram from the Acacia project to describe to first give an overview of all the different components that happen to make an accessible experience on the web, but then more specifically to draw your attention to the ways that the different technologies that I've been discussing so far actually get at different parts of this whole stack, and therefore actually need to exist and all need to do a good job in order to make sure that everything works correctly. Because although AT-Driver itself gives probably the highest level understanding, because it's giving you the most direct picture of what an end user, a screen reader user, is actually experiencing. One thing that approach really suffers from is there's not really you can't really localize problems. So if as a developer you just find the screen reader is saying the wrong thing, it's not necessarily clear why it's saying the wrong thing, because there is so many different layers and so many different there are so many different layers between the end user and where the document or whatever they're trying to view is coming from. So these other projects help to localize those things and help to test the distinctive components that make that experience even possible. So where we stand now is with actually implementing. We're building this as we're designing it, and to that end, we have a few implementations to help us do this. I mean, you saw the screen recording earlier of it actually running on Mac OS. So there have been a total of 4, although the first one that I'll point out here is currently defunct. We have these 2 that are based on operating systems themselves instead of being specific to a certain screen reader, and that would be the Windows AT-Driver server and the Mac OS AT-Driver server. And the way that those work, the way we develop those, is we actually just implemented a text-to-speech voice that's basically not performing the voice that Siri does. It's not actually enunciating or vocalizing anything. It's kind of like, to borrow a term from the testing industry, it's like a spy that just sits there. It's completely silent and completely useless to someone that actually needs a screen reader. But instead, it just kind of shunts the data that the operating system is giving it. And the strength of that technique is that actually we don't need to integrate with a screen reader. So the solution that we built to work with NVDA, for instance, for Windows, it works just as well with Narrator, because these screen readers don't actually know that they're being tested. They're just giving the speech that they want to enunciate to the operating system. The operating system is handing it to the voice. So we're not using that Windows implementation now at the time being. So we've kind of quit development on that for the time being, at least. Partially because we developed a NVDA specific solution that is implemented as a add-on for NVDA, the Windows screen reader. And we're maintaining that alongside Prime Access Consulting. And there's a 4th implementation that is not complete, but it's under construction right now, being implemented by Vispero, who also maintain the JAWS screen reader for Windows. And that's going to ship as a standalone, not a standalone, but a DLL that developers can choose to run alongside of their installation of JAWS. So I do want to give a shout out to the RAAT project, because that's the venue that's driving the implementation of AT-Driver. There's probably a pun there, but I'm not quick enough to point it out. So I'll just point it out. There's a pun there. You can insert it later if you want. But that is where we're doing the work to inform what the practical needs of a tool like this, at least at an early stage, and also to substantiate actual implementation. So I mentioned earlier in that recording I showed that was running an RAAT test. So the goal of the RAAT project, which is happening, it's its own W3C community group, and it's happening in parallel. Their goal is to promote consistency in the behavior of assistive tech. And again, like us, their focus at the time being is screen readers, but like us, they intend to expand that focus in time. But there's that whole process is involves a lot of work, and it is also distinctive because the actual enunciations of these screen readers is not standardized, and that's, I guess I wouldn't call that the problem, but that's the novel part as from a testing standpoint. So our work with AT Driver is to make it easy to collect the enunciations so that real human beings can kind of review them and say, is this correct or is this not, and why? But that's really a separate project that's just complementing this, and as I've said, substantiating our work as we try to make their lives easier and their work easier. So, but of course we do. This is just one use case, and so we're ultimately targeting web developers. That's who we want to serve, because we think that's where this will have the largest impact. But it's early stage yet, so that's where, practically speaking, we're getting a lot of our implementation experience. So with all that said, I can talk a little bit about future work, where we're going from here. You've seen where we are now, what we're capable of doing, and I thought I'd spare you a review of the specification itself. You're more than welcome to review it at your own leisure, but what we're looking to do now is to extend that specification, because right now it really does two novel things. It lets you subscribe to events, like speech events, so that you can learn what's being said, and also lets you communicate with the screen reader to simulate pressing keys, because that is how folks interact with their own screen readers, so they're able to do things like all these different motions that screen readers might do. But at the moment, it's limited to actually literally pressing keys. And so that this is somewhat of a limitation, at least when it comes to writing interoperable tests, because what it means is that although technically you can write a test that will, as you saw, like instruct VoiceOver to move to the next form field, that you're actually sending the literal key command that you would do for VoiceOver. And so if you wanted to write that, if you wanted that same test to run for NVDA, you'd have to write a slightly different test that used a different key combination, because NVDA is a different screen reader with its own user interface and own keyboard shortcuts. So from standards standpoint, that's not great. We can imagine like a library that would paper over that distinction, that they have their own abstraction and they can maintain the different key presses for each screen reader. But we really want to drive consensus among screen readers, at least from an automation standpoint, about what are the not just like the interesting things that the most interesting and most useful motions that a user might use, but also what the semantics are behind them. So what does it exactly mean to move to the next form field in all those different situations that someone might be moving to a form field. And so that's why right now this specification already has this concept of intents, but there's only one, and that is pressing a key. But we hope to extend the specification with further intents that have the whole range of things that are interesting to a screen reader, and that we can somehow convince all the screen readers are interesting. So that would be something like move to next form field. So you could write that one test for that situation and expect it to run the same way on all these different screen readers. So that's probably the most near-term thing that we're going to do. But alongside that, and actually happening right now, is we're extending our implementation reach, and so we're trying to implement for Android's TalkBack screen reader and Apple's mobile's, that's a typo, mobile VoiceOver screen reader. And that's some really interesting work because of the restrictions on those platforms that I can't really speak that much about, because it's above my pay grade, but folks at Boku are really pushing the boundaries there and doing some interesting work, so you can watch the space for more on that. We also, of course, as I mentioned before, want to extend beyond screen readers. Although I've used the term screen reader a number of times in this talk, it's always on my mind that that's just one kind of assistive technology that we want to be compatible with, and we want to really push the design of the standard as soon as is feasible for us into the different types of ATs and into the different paradigms, because that will probably have significant ramifications for what the protocol does and how it's shaped. And so this would include things like magnifiers or braille displays, the list goes on. And finally, I know, well, something that I'm personally most interested in about all this, but this might be very far future, but is learning if and how this protocol can make sense and be useful beyond the web platform. Because although we're standardizing under the W3C and we're using it for web pages right now, it's really about screen readers, and screen reader users do things beyond just using their web browser. And as such, it could be interesting to folks. It should be interesting folks that are making experiences outside of the web browser to also have this kind of insight. So they're making a native app and they want to learn what does it look like, or what does it feel like, or what is the experience like for someone using the AT, even though my project has nothing to do with the web browser. And that I don't take for granted, because I think there are a lot of novel problems there, and I'm not sure that even the decisions we've made so far aren't painting us into a corner. Because, for instance, I mentioned that this is all based on WebSockets, and it's not really clear to me, even now, if someone that's making a native app would want to have a testing infrastructure that has to drag in a whole dependency to speak WebSockets, because they're not web developers, they're not using any other part of the web platform stack. So maybe that part of the protocol doesn't make as much sense. But these are things that, for what it's worth, are on our mind, but we also recognize they're very far future, because practically speaking, we're really trying to limit our scope so that way we can get something shipping that actually helps people today. And I think that's pretty much all I have to say about that. So I have, just running in the background here, like I said, if you're curious, this is another implementation. This is running with Chrome and NVDA screen reader, and a different series of tests from the RAE project. So that's all I really have to say. Unless you folks have questions, I can open up for questions.
So do we have questions?
I did my job.
That's all right. Great, great talk. Thank you very much, Mike. All right, great. While they are setting up, I can introduce our next speaker. We have Thomas Steiner. He goes by Tom, if you can't remember his full name. And he's a developer relation engineer at Google. He's focused on built-in AI, WebAssembly, and advanced web API, aka project Fugu. He is very interested in having honest dialogue with other browser vendors. Being in Chrome DevRel also means he is also doing lots of web DevRel. Today he is going to talk about built-in APIs for the web, but that's not the only thing he is onto. Tomorrow at 12, he's also organizing a breakout session on cross-origin storage. If you're interested in AI, built-in cloud, or client-side models, and when to use which approach, including when to not use AI, you should definitely attend tomorrow's breakout session. And to you, Tom, now.
Yeah, thank you very much. All right, so my name is Tom Steiner. I work for the Chrome team. I'm here today to talk about built-in AI APIs for the web, exclamation mark or question mark, we will see. If you want to add AI to your web application, you have a number of options. But before, let's actually think of an application where this would maybe make sense. So imagine you were to build an application that lets people record their ideas and organize them. So let's say ideas.example.com. And the features of this application are something like recording ideas by voice. So let's say you walk around and you are a composer and you have this amazing idea of, I don't know, a tune. So you're like, remember this and I want to build a song or create a song based on this thing that I'm humming right now. So native operating system level keyboard dictation, of course, doesn't kill that use case. You need to actually record the voice and then maybe have the voice transcribed. You can, of course, also enter ideas by keyboard. So if you walk around and you have this idea for an amazing blog post or a catchy headline or something, you can just type it in. Ideas can be visual as well. So let's say you are planning your living room redesign, and you see this piece of furniture, and you draw a sketch, and I don't know, with the measures and dimensions of the piece of furniture. You want to grab ideas by photo, so you walk around and you see this amazing fabric design, you take a photo, and you just want to recall this design. And possible AI use cases. Now imagining this application that I sketched before, you could ask the thing to return all of your ideas where you hum, because this is a way to just quickly get back your composing ideas. You could tell the application, hey, based on this headline, write an opening paragraph. So just some sort of writing task. You could ask an AI, how much wood do I need given this sketch? So remember the furniture use case. Or you could say, where can I buy a t-shirt with this design? So if you have taken a photo of some fabric design, for example, you could just tell the AI, rewrite this rough idea more formally. So if you want to share it with someone, and then share this idea translated to Japanese with my friend Eiji. You could also say like, hey, summarize all my ideas that I dictated or that I entered in the application yesterday afternoon. So there's a bunch of ideas for possible AI use cases. And if you want to actually do that now and add AI to this application that I sketched, option one would be to just use something that is in the cloud. So some sort of API where you call some sort of service and then get the magic in the cloud somewhere and the results back. Positive aspect of this, of course, some of the most advanced models run in the cloud and only in the cloud sometimes even, so you get access to those. The app itself can remain small because all of the AI, logic, magic, whatever you call it, is running in the cloud, so your actual application can be really small on the hard disk of the device or on the device memory. Because everything runs in the cloud, you can run on commodity hardware like lower cost Android devices, for example. You don't need high-end devices where you can run. But then the negative aspect, this can get expensive relatively fast. It makes cost prediction unclear. So if you want to offer a subscription, should you charge users 10 euros per month or $10 or whatever, or should you like make a usage-based billing, whatever? So it can be expensive and complex to calculate cost. A big privacy problem, of course, is you need to send your user data to the cloud, which can or cannot be an option. And because you need to send data to the cloud, it doesn't work offline. Which brings me to option two. You can download AI models locally and run them on the client. This is obviously privacy preserving because all the processing happens locally. It works offline once the model has been downloaded and cached. It is free to you as a developer because all the inference is happening on the user's device, so there's no cost for an API service or something. Negative aspects, of course, the model downloads can be prohibitively large and require a lot of disk space, so all of a sudden your application might require, 4 gigabytes of disk space if you ship a large, transcription model, for example, which also means this may not necessarily work on all hardware. So if you have a low-cost Android device, it may just be not fast enough because it doesn't have a powerful enough or not even have a GPU. And this also limits, to some extent, what models you can use. So if you have a model that is super proprietary, you want to super protect it from someone stealing it, this just can't work on the web because there's no way to have DRM, if you will, for AI models right now. Shameless plug to the breakout session tomorrow. So there's an idea that we have that we want to discuss with you all for this model downloads use case. So come tomorrow to the cross-origin storage breakout session. And with this, I want to move over to the proposed option 3, which is to make a shared AI model available to web APIs, which we in the Chrome team called built-in AI. It has the same more or less pros and cons, so privacy preserving because all the processing happens locally. It works offline once this shared AI model is downloaded and cached by the browser. It is free to the developer because all the inference happens on the client. And then I've moved this negative aspect of the model download up a bit and made it a plus minus because it still obviously is a one-time cost, so you still need to one-time download the application. But then the idea would be once you continue with the application, of course, the model is already there. And because it's shared across all the origins of the app, of the apps that you navigate to, chances are the more popular this gets, that the model would already be there. Again, some limitations. This may not work on all hardware or be slow. And it also limits what models can be used because you're bound to whatever model the browser ships. And we see the model mostly as an implementation detail. So it should not matter really what the concrete model is because the use cases are addressed by the model in a well enough way. So that's our point of view here, but we can talk about this a little later. And we brought these ideas forward, and actually they made it into the Web Machine Learning Community Group charter at the W3C. So you can see their scope of work here. So we have so-called task-specific APIs, where there's a well-defined task like detecting the language of something, translating some input text, rephrasing input text, proofreading something that the user has written. So something that is well understood. It's a well understood task. There's no wiggle room. It's just a translation or it's just a summarization. And then the second point here is the so-called prompt API, where it's freeform. It can be anything. It can be something that is on a scale of 1 to 5, how positive or negative is this review? So some sort of classifier. It can be something that summarize this and replace every second E with whatever. So you get the point. So it's something that is just not well defined. There's a number of ideas that people might be having that we think could be realized with this API. And as I said, this work is being in the community group at the W3C. So there's some draft specs that people have come up with here. So there's a translator and language detector APIs that define the language detector and the translator API. There's the writing assistance APIs, which define the writer and the rewriter API and the summarization or summarizer API. So you can already look at those draft specs. And then for the prompt API, we are a little bit earlier in the phase of making this something a little bit more formal. There we have an explainer so far, so you can check out the explainer. There's no spec draft quite yet. And going back to the application that I just sketched before. So if you have something like list all my ideas where I hum, this would be a task that could be addressed with the prompt API with audio input. So the prompt would be, well, list all my ideas where I hum. And then the input would be your recording ideas, like the actual recordings, like a WAV file or MP3 file or something, that you would then feed into the API, and it would come back with only the ones where you hum. So it would have an understanding of what humming is. Based on this headline, write an opening paragraph. This would be a task for the writer API. How much wood do I need given this sketch? So the furniture use case, if you remember, this would be for the prompt API. So you would give it the sketch. You would ask it this question about the sketch, and then the API would come back with hopefully a useful response. Where can I buy a t-shirt with this design? So if you have the fabric design use case, this would be, again, a use case for the prompt API with an image input. Rewrite this rough idea more formally, which would be obviously a case for the rewriter API. Share this idea translated to Japanese with my friend Eiji would be a task for the translator API. And then the last point is here, summarize all my ideas from yesterday afternoon. This would be a task for the summarizer API. So this is a little bit abstract, and I confess that it's maybe a little hard to follow. So I just thought I do a little bit of live demoing here of the implementation that we have in Chrome. So let me just move over to here. Let me increase the size here and open DevTools and increase the size here as well. So this is a super simple demo website, and I just took some text, so the bio that I used for submitting this presentation, and this is exposed to here. So here I have a global variable that gives me just the contents of this div. So the first API that I want to show you is const detector. Detector equals await language detector dot create. So now we have a language detector, and if you look at the detector, you can see it has a bunch of fields like the expected input languages and so on, but it also has simply a detect function. So I can give it my bio dot inner text, and this is async, so I need to await the thing. And it gives me back an array with 2 entries. So if I open the first one, you can see with 99% confidence, it thinks that the detected language of this is English. So that's not super exciting quite yet. For reuse, let's just store this in a variable, dot detected language, and call this L. Wait. Yeah, const. And I think I don't need to await here. So L is now N. Perfect. Okay, so now that we know that this is N, I can show you the next use case, which would be const translator equals wait translator dot create. And this is not as simple as before. So here I need to give it something where and from to translate to and from. So I need a source language, which is L that I just defined as English, or well, defined. It was detected. And then I have a target language. So obviously here we make that Spanish. And now we have a translator that can translate. So let's do just that. And we give it the bio.inner text. Again, we need to await. And then we have the result here. So Thomas Steiner es un ingeniero de relaciones con desarrolladores, blah, blah, blah. So you can see it gives me the translation back. All right, so that's this API. So language detector and translator obviously go together quite well. This is maybe Generation TikTok, so we all have an attention span of not 2 paragraphs, but maybe just a few bullet points. So let's use the summarizer for this. So we have const summarizer equals summarizer dot create. And oops, it's async. So I need to do this. So now we have a summarizer, and obviously I can fine-tune this a bit. I can tell it what kind of summaries it needs to give me. So by default, you can see the default is key points. So let's give it something to summarize, which is my bio.inner text. And oops, this is also async, so we need to await it. And then hopefully after a little bit, we get the result back. And the suspense is incredible. Come on. Be faster. Give me something back. Tempting the demo gods here. Come on, say something. So this is running in Chrome Canary, so maybe today's Canary broke it. Let's see. Interesting. So I don't get a summary back, but imagine I did. So this is live coding at its best. Maybe it will come back eventually. Maybe we just need to trigger it again. Let's see. I could, but like I want to present a lot of things, so I'm going to rush through it, and then I will answer to these kind of things later. Okay, so seems like today's canary broke the summarizer API. It's early days for all of those APIs, very obviously so. But yeah, so this is like two APIs that you get make sense with textual input. I want to show you another use case here, which is this one. This is actually the code of this application, so let me also zoom in a little bit. And right now, you can see down here, there's something more. So there's a prompt input field. So I can just tell me a random fact. So I can just ask it to tell me a random fact, and it spits out a random fact. So this is not very useful yet, because in many cases, you want to do something that is more customized. So this brings me to the first example here. So this is right now hooked up to, where is it? Here, script basic.js. So let me show you script basic.js. Step one for working with these APIs is npm install React. No, it's not. Step one is just essentially to, this didn't, like no one laughed, okay. You laughed when I say no one laughed. Okay, so how do you work with this? Well, you first get access to some DOM nodes here, and then just a basic event listener for the submit event. We get the prompt value that we need. We reset our inner HTML here, and then the actual magic happens in these two lines, where we have the language model that we create as before. You sort of see a pattern already, so all of those have a static method, create, and then this gives you back the thing, like the summarizer, the language model, the whatever, and then we can send, in this case, to the language model a prompt streaming prompt. All of the other APIs have streaming variants as well. I didn't show those because it's a little bit more code. Like here you can see I need to, of course, go through this readable stream and then read chunk by chunk what is given back by the language model here. And yeah, you've seen it was sort of printing chunk by chunk the response that I came up with here, that it came up with here. Okay, so this is very simple, but now let's make this a little bit more complex. So for this, I want to move to the next demo, which is this one. So instead of the basic script, I now hook up the logic to the JSON schema one. And the idea here is we want to build some sort of classifier. So for a classifier, we just want a Boolean yes or no response, which now I can do by specifying a response constraint. And this is the simplest possible JSON schema, but a lot of the JSON schema format is supported by this, so you can make it a lot more complex. But for the sake of this simple example, I just make it a Boolean. We have the same code as before, but now for the prompt streaming, instead of just the prompt, I also add my prompt constraint. So now we force the model to respond with just a Boolean value. So if we go back to here and reload, now we need a Boolean question like, I don't know, any Boolean question that comes to mind? Will it rain today in Galicia? And it will rain today. Okay, of course, it is a language model. It doesn't have function calling quite yet, so it can't call into some sort of actual weather service. So it just, whatever, came up with a response. And I guess if you submit this a bunch of times, at some point we will get false back. So in this case, it continues to respond with true. So maybe it is true, who knows? Historically speaking, it does have some experience with it raining here. So my taxi driver to here said, in Galicia it's always raining, so it does maybe make sense. Okay, so this is step one for having a classifier. Now I want to move to the next variant of this script. So let me just hook it up to the HTML. And let me show it to you. What we have now is a reference to this image. So you can see this is the image. and I'm referencing it in this variable. And now my prompt becomes slightly more complex. So you can see now my prompt has a role of user. It's an object in an array. It has content, again an array with a type text, which is my textual prompt as before. But this time I'm also passing in an image. And then the rest is the exact same as before. Let me, for the moment, uncomment the response constraint. So now we can just get a free-form response back. So let me go to here, reload, and then I can say, is there a person on this image? And now it will hopefully respond with, yes, there's a person on the image. And yeah, like to a human, this makes a lot of sense. But yeah, it is not very useful to then sort of parse out, does it respond with yes or does it respond with no? So now it makes sense to come back with our response constraint here and say, now we want to have a true false. So let's ask the same question, is there a person in this image? And hopefully it says true now. Yes. Okay, so you can see how this can be useful. You can make this any kind of application where you give it something and then you ask it, hey, true or false. Or you can say, like, is the mood of this positive on a range from 1 to 10? Or, like, you get the point. You can make this really free from anything. I want to show you one more cool use case that you can realize with this. This is the prompt API connected to SQLite. So if I reload this, I can create a new conversation. And I can now say I want to add an image to this conversation. And I take the Tower of Hercules. And then I can ask it something like, describe this image to a non-cited user. And then I can ask the AI to do that. And then it responds with, well, it got the point wrong, the Torre della Torre. That's not the Torre della Torre. But the rest seems like it makes sense. So it sort of describes what it sees on the image. And then I can also ask more things. So this is an ongoing session. So I can say, like, is this close to the water, for example? And then, oh, it gets it actually wrong. That's interesting. So including ambitious to show a park with a tower in the center and the ground below it. So it might look, like, to be fair, it sort of looks a little bit artificial because it's very mirror-y. So I guess there was some touching of this image in place. But yeah, again, you get the point. It still has the ongoing running session here. And what I can do now is I can just reload this application. So if I go here, actually I can even close it. So I can close this entire application, go back, reload it, and it has restored the session from SQLite. So it has sort of serialized the entire session into SQLite, and then I can continue where I left off, and I can ask, like, are you sure? I'm sorry, I'm not sure. So you can see it still has, even despite me having closed and reloaded the entire application, it has restored the context and so on. And I can do the chat GPT kind of thing. So I can now in parallel create a new session and I say, like, tell me a joke. And you can see how it also updates in real time here the conversation summary. And then I can switch between those and say, like, what if I give you one more hint? And then I can add another image. So this one, yeah, so this is a shot of La Coruña. And by the way, so you can see this is, it has been touched, right? You can see this is not an actual sea level image. So there has been some photoshopping happening. So I can add this image now. And I can then send this. And now it sort of corrects itself a little bit and says, yeah, now it's close to the ocean. So you can see this is all running and restoring the context. I can then go back to my jokes session and say, like, well, let's do a reload in between. I can go back to my jokes session and say, like, this is active now, it's yellow. and I can just ask it another, and it will tell me another joke. So you can see how this become useful, and I can actually make this completely work offline, so I can go offline now. Will Google Slides, yeah, hopefully Google Slides will still work. So I can take this entirely offline now, so closing off the Wi-Fi connection and ask it to tell me one more joke. And it will tell me one more joke. And because this is a PWA, I can even install it, close it, and hopefully, yes, we are back. So you can see how this makes sense. And by the way, something I didn't show you, it also has some session statistics. So you can, as a developer, be aware of how much the session has tokens left, how much tokens were consumed, and so on. So this is Chrome's implementation so far. I want to go back to the slides. So we have seen the live demo of this. We've seen the live demo of that. Both applications, by the way, or like this is a demo, not real super useful application, but like everything you can just access yourself and try the APIs if you set the right flags. I want to show that people actually find this useful. And we just had Google I/O. This is the full talks. If you want to get more detail, scan this QR code or enter the URL into your browser. But from this talk, I want to just show you a bunch of use cases that people have been realizing with early versions of those APIs that were made accessible to them as Origin trial. So one is a company from Japan called CyberAgent, and they run sort of like a blogging platform. So for them, it's all Japanese, so maybe someone reads it. You can start with some sort of body text, and then with this body text, click this magic button, and it will give you some heading suggestions for how to title your blog post. You get some suggestions, and then from those suggestions, you're going to say, I like this one, but make it a little shorter, for example. So it will take the existing one as input and say, like, hey, take this, but make it shorter, or take this and make it more funny, or whatever. So you can see this can be actually really useful. And CyberAgent, this blogging platform, have tested this with real bloggers of theirs, so high-profile bloggers. They came to the Google office. They tested the application. They made it available to them and worked with a bunch of their top content creators, and they found it actually quite useful. Policy Bazaar is a company from India. They're in the insurance business, and they have this chat widget here. The thing is, India obviously has a lot of languages, so people would be able to type in their native Indic language. They would then use the language detector API to detect what language is the user typing in. They would then translate this Indic language to something that the support agent on the other end would speak, so maybe Hindi, maybe English. The support agent would then respond back and then translate the response back to the user's native language that was determined by the language detector API. So there's no like, hey, please type in English kind of ableist feature in this app. It's just, hey, just ask a question, and the API in the background deals with this. Nika Fashion, a company from India in the fashion business, obviously, they use the prompt API with image input to let their users say like, hey, I have this outfit and I need something that is fitting. So you can upload whatever, like these yellow, beige, whatever pants, and say like, hey, I need a sweater that goes well with it. And then the application will give you some suggestions powered by extracted features from the image. Chefkoch, a German company, they are in the business of recipes and recipes online. And what I do a lot, what my parents do a lot, we have some sort of recipe, maybe from our grandparents, that is handwritten, and we just want to digitize it. So they have this use case where they use the prompt API with image input to OCR, essentially handwritten text like this, and then make the AI make sense of it and separate in what is the ingredients, what are the preparation steps, and so on. So you can see this is also something that probably some of you can relate to as a use case. Brightsides, company working with a lot of publishers, they have this CRM, content management system, CMS, content management system, where the authors, like the writers, have this internal interface. They upload an image, like in this case these shoes, and then they can use the prompt API with image input and have an alt text suggestion generated, and then the human in the loop can say like, yeah, this is actually a pretty adequate description that makes sense as an alt text, but they can then modify it, obviously, if it's not great. And they can also like get a figure captions, so captions for a figure are different from the alt text, so they can get both. With the prompt API, they can just tell the API what they want for this particular use case. And then the final use case here is OLX. They run a chat that also allows people to have audio messages, but this is end-to-end encrypted. And I hate when my wife sends me text messages, like audio messages. So WhatsApp sort of has started doing it, but here this is all web-based, where it will just have the local audio end-to-end encrypted still, but of course you have it on your device, and then it would transcribe on the device what people were saying. So this is a company from Brazil, so you can see this is in Portuguese here. All right, back to some of the problems with this. I said before in the minuses, like in the negative aspect, this does not necessarily run on all devices. For example, it does not run on Android right now. So Android is, of course, a very important platform. So with the Firebase team, they sat together and said, like, hey, we need some way to support Android. And they came up with what they call the Firebase AI logic, which is a hybrid experience. So it would use the built-in AI APIs if available, and if not, fall back to the cloud. So obviously, there's a big caveat. If your use case requires local processing for, I don't know, privacy reasons, for legal reasons, of course, this is not something that you necessarily can use. So careful here. It's mostly meant as a fallback logic where it can be done and where local processing is not a strict requirement. We were seeking feedback from a couple of folks and people, and some of them might be here. So there's the tag. So we filed for design feedback of the APIs. In the tag, we asked WebKit and Mozilla on their particular standards repositories. And you can see there's some discussion already happening, but obviously this is only the starting point of the discussions. And if you want to learn more about Chrome's implementation of those APIs, we have an article, Get Started with Built-in AI, or again, watch the talk from Google I/O, where I go in some more detail. And yeah, this is, as I said, not so much about Chrome's implementation. It's mostly about these APIs for the web platform. So does this make sense? And with that, I want to thank you very much for listening, and I think we have time for questions.
Thank you very much. We only have questions for two people, 2 questions. Okay.
Hi, nice talk. I guess my main concern is, say I'm browsing the web and a website has an origin trial. When I last tried this API, there's no kind of pop-up for the user saying Chrome is about to download 2 gigs of data or so. Will that be a thing when it's shipped?
So you mean there was no information that a model was downloading?
Yeah.
The API exposed this information from day one. I guess websites are still discovering what are best practices for exposing this. There is, when you create the object, there's a monitor that gives you information about the download progress. There's also an availability function. So if you watch the talk, I go into this in some detail. It goes into, like, maybe let's get the QR code up again if people are interested here. So there's an availability function. So you can ask it, hey, what is the availability of this thing, like the translator or the language detector or whatever. And it will then say available, which is the optimal use case. Everything is up and running, ready to go. Unavailable, this means the device doesn't even support this API because the GPU is not powerful enough or whatever. And then the 2 other states are downloadable, which means, yes, this device is capable. You can start triggering the download of the model, and downloading. So the download is actually right now going on or ongoing. And with this monitor, you can then hook into the event and show a nice progress bar to the user. As I said in the beginning, the motivation for these APIs to be in the browser built-in would be once this is downloaded by one single application, all the other applications, no matter what, would profit from the download. But yeah, so I think right now this is mostly just our partners still learning how to expose this information, because in the lab, when they hack on this in a hackathon or something, yeah, of course, they never encounter the use case where the model is not ready yet, or they did it once but then forgot that this is state. So long story short, it's just poor UI, but yeah, for pardonable reasons of the customer or partner, that they haven't exposed this information yet.
So I have a question.
I don't see.
I'm here.
Ah, here. Okay.
How do you foresee this ever becoming an interoperable web API? I think like barcode detector is an example of an API where it's reliant on some sort of device processing, but it's a fairly consistent, does this QR contain a URL, and here it is. Whereas this is, I would give you free text, and the model that Chrome chooses in a specific version processes that in a specific way. And if Google decide actually we want to update that model, suddenly every website that's using it's going to start working differently. Models already, like if you're using a very specific AI model, your prompts are very specifically tailored to that AI model. And I worry that you're going to ship a specific model, people are going to be reliant on it. And then say if Mozilla want to ship their own and they're using a different model, it's just going to be, am I in Chrome, do this, am I in Firefox, do this, and potentially even versioned to browser versions from the same company.
Yeah, so my response to this is twofold. So essentially, it's different for the task-based APIs and the prompt API. So the task-based APIs are the ones where there's a well-defined task, like a translation. And people have different translation services today. So you can have human translation, machine translation. You can use different machine translating services. And there's well-defined benchmarks even for saying like, hey, how good of a translation is this? So we have agreed on judging these sort of subjective things for quality. So the vision there would be actually just make this work well enough, and you may have noticed there's no prompt at all involved in those for the user. These APIs have been implemented by Edge, and in Chrome, what we use is Gemini Nano. What they use in Edge is Phi 4, so a model that is built by Microsoft. And they have made these APIs work. So far they've implemented the summarizer, the prompt API, I think the writer and the rewriter API as well. And the assumption would be we can just agree on making those tasks work well enough based on existing benchmarks. I can say like, of course the output is non-deterministic, but still running a benchmark, we can say like, yes, this is a good, adequate translation of this input text. For the prompt API, it's a little bit more complex. So because the model is small, both like Phi 4, the model that Microsoft chose, Gemini Nano, there might be some more prompt engineering involved, where you sort of trigger your, or tailor your prompt to the particularities of the model that is in use. And this is a risk, and this is a true risk. So I think right now we're learning on the implementer side, how much does this actually happen, that people prompt engineer? And if we see there's a lot of prompt engineering happening, there might be just a way to fine-tune the model. So if everyone says like, please respond with yes or no, in the end what they want to get is a Boolean response, right? So if you have this kind of thing, we can fine-tune the model and say like, hey, there seems to be a use case where people have this particular expectations. And then in the end, this led us to saying like, hey, wait, actually JSON schema might be the response here. We also have regular expression that you need to match. So over time, we think like fine-tuning the model, making it work with the use cases that we detect, having structured output as the overarching term for this, may address some of the use cases. And then lastly, and then this is where this last bullet point here, proofread input text, proofread input text came from. If we see a lot of people use the prompt API to do the same thing, we just create a higher level task API based on this. So you could be like, oh yeah, like your use case, detecting QR codes. We're like, wait, a lot of people are asking the prompt API to figure out the QR code, which is like a made-up example, okay? But you get the point. Then we would say like, yeah, maybe we should just have a higher level QR code detection API on the web. And this is where the proofreader API proposal came from. So we were seeing a lot of people were using the prompt API for detecting proofreading or realizing proofreading use cases. And now we have a proposal for such an API as a high-level API. So we think on the Chrome team, the model is hopefully something that can be dealt with as an implementation detail. Of course, it's very early days, so we will see if this assumption is true. We are starting an origin trial with the prompt API with image and audio input and, of course, textual input. So people can play with this some more. Most importantly, if you go to a lot of slides, here we go. If you go to the documentation here, we have something called EPP, Early Preview Program, where we ask people to join this early preview program, which allows us then, if you join that program, to ask you and survey you about your experience with the API. So by having a back channel to the people who participate in those experiments very early on, and also like I go into some detail in this in the talk, we also invite partners, like big partners that you've seen mentioned on the slides, but also other partners that you don't see mentioned. We invite those partners into Google, and also try to get addressed their use cases that they have as a big corporation, big company. But then also, as I said, the EPP is meant for developers, regular developers who just are interested in advancing these features or maybe even stopping them, who knows. So just by getting involved early on, we hope to hear a lot of feedback, survey you, address the feedback accordingly, and then launch APIs that are actually useful to people, like the task APIs, where we see, for example, Mozilla see the use case of translation on the web, and they've come up with, you might even be involved, I don't know. I don't know you, so I'm not sure if you work for Mozilla, I don't know. So there is a proposal from Mozilla, for example, for an alternative shape of the translation API, but I think in general, for the task APIs, most people would agree, sort of, on the use case of those APIs. So this was a very long-winded response. Hopefully, does it, satisfy your, okay.
Cool, thank you very much, Thomas.
Yeah, thank you very much.
All right, so this was the last talk, and people who have signed up for the city tour, you should head to the entrance of Plexco. There's a bus waiting for you, and all right, have a good evening, and let's see each other tomorrow.